Beneath the surface of our oceans lies a world more alien than the surface of Mars, a realm where sunlight has never touched, where the pressure could crush a human being in an instant, and where creatures exist that defy every law of biology we thought we understood. For thousands of years, humanity has gazed up at the stars, dreaming of what mysteries the cosmos might hold. Yet right here, on our own planet, covering more than 70% of Earth's surface, lies an abyss so profound, so utterly unknown, that we have better maps of distant planets than we do of our own ocean floor. The deep sea is not simply dark water extending downward. It is a frontier of incomprehensible scale, a vertical universe descending into blackness where the rules of surface life cease to apply. At depths beyond 200 meters, photosynthesis becomes impossible. Beyond 1,000 meters, the pressure exceeds 100 atmospheres. And yet, life persists. Life flourishes. Life evolves into forms so bizarre, so perfectly adapted to conditions that would annihilate surface dwellers, that encountering them feels like discovering biology from another dimension. Tonight, we descend together into this abyss. We will explore mysteries that have haunted oceanographers for generations. We will encounter phenomena that challenge our understanding of physics, biology, and the very nature of consciousness itself. We will investigate disappearances that have never been explained, discoveries that rewrote scientific textbooks, and encounters that suggest our oceans harbour secrets far stranger than most are willing to acknowledge. This is not a journey for the faint of heart. The deep sea is a place of primal terror, where ancient fears lurk in every shadow, where the darkness is so complete that many creatures have evolved to create their own light. It is a place where time moves differently, where species unchanged for millions of years glide through waters that have remained constant since before humanity existed. Prepare yourself. We are about to explore the last truly unknown place on Earth, a place where maps end and mystery begins, a place where every expedition discovers something unprecedented, a place that reminds us, with humbling certainty, that we are not the masters of this planet we call home. The abyss is waiting, let us descend. The bloop. A sound that should not exist. In the summer of 1997, deep in the cold waters of the South Pacific, something impossible happened. The United States National Oceanic and Atmospheric Administration operates a network of underwater listening devices originally designed during the Cold War to track Soviet submarines. These hydrophones, scattered across the ocean floor at strategic points around the globe, listen constantly to the acoustic symphony of the deep. They hear whale songs, the grinding of tectonic plates, the rumble of underwater volcanoes, and the steady background noise of a living ocean. On this particular day, their computers registered something that should not exist. The sound was detected by sensors over 5,000 kilometers apart, suggesting a source of almost unimaginable power. It began as a low-frequency rumble, rapidly ascending in pitch over the course of approximately 1 minute, before fading back into the ambient noise of the ocean. The acoustic signature was unlike anything in the database. It was not geological. It was not mechanical. The characteristics of the sound, its pattern and frequency modulation, suggested something biological, but nothing biological that we know of could produce a sound of such magnitude. The scientists at NOAA named it the bloop. The nickname seemed appropriate for something so strange, so unprecedented. But beneath the whimsical name lay a profound mystery that has never been satisfactorily explained. When acoustic specialists analysed the bloop, they found characteristics consistent with biological sources. The sound bore resemblances to vocalizations made by marine mammals, but scaled up to proportions that seemed to violate the laws of biology as we understand them. To produce a sound detectable across such vast distances would require an organism of almost impossible size. Calculations suggested something far larger than a blue whale, the largest animal known to have ever existed on Earth. The blue whale, at lengths exceeding 30 meters and weights approaching 200 tons, represents what biologists consider the upper limit for animal size on our planet. The square cube law dictates that as an organism grows larger, its volume and weight increase faster than its structural strength. A creature much larger than a blue whale would face insurmountable challenges in supporting its own body mass. Even in the buoyant environment of the ocean, The heart alone would need to be the size of a small car. The blood vessels would need to withstand pressures that would rupture normal biological tissues, and yet the bloop suggested something even larger. Some scientists proposed alternative explanations. Perhaps it was the sound of an iceberg fracturing and grinding against the seabed, amplified and distorted by the unique acoustics of deep water. This theory gained some traction when researchers noted that the bloop originated from a region near the Antarctic, where massive icebergs are common. In 2005, NOAA officially attributed the bloop to ice-related phenomena, specifically icequakes from large icebergs calving or fracturing. But not everyone was convinced. The acoustic signature, when examined in detail, contains subtleties that seem difficult to reconcile with ice mechanics. The frequency modulation, the way the sound rises and falls, follows patterns more consistent with biological vocalization than with the chaotic fracturing of ice. Moreover, the intensity and the coherent structure of the sound waves suggest a focused source, not the diffuse acoustic chaos of breaking ice. Consider also the location. The bloop originated from coordinates approximately 50 degrees south latitude and 100 degrees west longitude, a remote region of the South Pacific far from any landmass. The depth in this area exceeds 4,000 meters in places. The water temperature hovers just above freezing. The pressure is nearly 400 times that at the surface. This is not merely hostile to life as we know it. This is an environment so extreme that until very recently we believed nothing complex could survive there. We were wrong. Every deep-sea expedition discovers new species. Every submersible dive encounters organisms that seem to belong in science fiction rather than biology textbooks. We have found fish with transparent skulls and tubular eyes that look perpetually upward. We have discovered jellyfish as large as small cars, with tentacles extending over 30 meters. We have encountered squid with eyes the size of dinner plates, the largest eyes in the animal kingdom, evolved to detect the faintest bioluminescence in absolute darkness. Most significantly, we have learned that the deep-sea harbours creatures far larger than we once thought possible. The giant squid, long relegated to mythology, was finally photographed in its natural habitat in 2004. Specimens have been found measuring over 13 meters in length. Its larger cousin, the colossal squid, may reach lengths exceeding 14 meters and weights of over 700 kilograms. These are predators of enormous size, hunting in the blackness of the deep sea, engaged in epic battles with sperm whales that dive to depths of over 2,000 meters to hunt them. If squid of such immense size exist, what else might lurk in regions even deeper, even less explored? The bloop was detected at a frequency range that suggested the source could have been anywhere from 1,000 to several thousand meters deep. At these depths, we have explored less than 5% of the available habitat. The deep sea is vast beyond human comprehension. The abyssal plains alone cover more area than all of Earth's continents combined. The trenches, the deepest parts of the ocean reaching down nearly 11,000 meters, remain almost entirely unexplored. In these lightless depths, evolution has had billions of years to produce forms of life we cannot imagine. The deep sea is the oldest ecosystem on Earth, its conditions remaining stable for hundreds of millions of years. While surface life has been repeatedly devastated by mass extinction events, asteroid impacts and climate shifts, the deep ocean has remained largely unchanged. Species that went extinct on the surface may have persisted below. Evolutionary lineages we believe long extinct may continue in the abyss, unknown and unseen. Consider the coelacanth. This ancient fish was known only from fossils and believed extinct for over 65 million years. Then, in 1938, a living specimen was caught off the coast of South Africa. The scientific community was stunned. Here was a creature unchanged, a living fossil that had somehow escaped detection for millions of years despite being over 2 meters long. If something as large as a coelacanth could remain hidden, what else might exist undetected in the vast expanses of the ocean? The ancient mariners were not entirely wrong when they wrote, "Here be monsters," on their maps of unexplored waters. They simply lacked the technology to discover just how right they were. The bloop has not been heard again. In the decade since 1997, despite continuous monitoring by an even more sophisticated array of hydrophones, the sound has not repeated. Whatever created it did so once, or at least only once that we detected. Perhaps it was a vocalization made only in specific circumstances, a mating call or territorial display. Perhaps it was a distress signal from a dying creature. Or perhaps it was something else entirely, something we lack the framework to even properly consider. What haunts researchers is not just the mystery of what created the bloop, but the unsettling realization of how little we actually know about the acoustic environment of the deep ocean. The bloop was loud enough to be detected across thousands of kilometers, but how many quieter sounds have we missed? How many creatures vocalize at frequencies we are not monitoring? How much communication, how much biological activity, how much life exists in the deep sea that we have no awareness of whatsoever? The ocean is not silent. It is filled with sound, a vast and complex acoustic environment we are only beginning to understand. Whales sing songs of such complexity that linguists have studied their structure. Dolphins and porpoises use sophisticated echolocation to navigate and hunt. Fish produce sounds through specialized muscles, swim bladders, and even their teeth. Snapping shrimp create sounds louder than a jet engine in their tiny claws. The ocean is full of voices, but some voices we have heard only once. The bloop remains officially unexplained in the minds of many researchers who have analysed the data. It represents a reminder that our planet still holds profound mysteries, that vast regions of Earth remain as unknown to us as distant planets, and that the oceans, despite centuries of exploration, continue to guard secrets we may never fully uncover. Somewhere in the deep Pacific, in waters so remote that no human eye has ever witnessed them, something made a sound powerful enough to echo across an entire ocean basin, a sound that suggested a creature of impossible size. And then, as mysteriously as it appeared, it fell silent. The hydrophones continue to listen. The deep sea keeps its secrets. And we are left to wonder what else might be down there, waiting in the darkness, unseen and unknown. The Mariana Trench, the deepest darkness. If all the water could be drained from the Pacific Ocean, the landscape revealed would be more alien than the surface of Mars. Vast plains stretching for thousands of kilometers, mountain ranges taller than the Himalayas, canyons that dwarf the Grand Canyon, volcanoes that would tower over Everest. And at the eastern edge of this drowned world lies the most extreme feature on Earth's surface, the Mariana Trench. This is the deepest place in the planet's oceans. A crescent-shaped scar in the seafloor stretching over 2,500 kilometers in length and 69 kilometers wide at its broadest point. The trench was formed by the collision of two tectonic plates, with the Pacific plate subducting beneath the smaller Mariana plate, creating a chasm that plunges down into darkness beyond human comprehension. At its deepest point, the Challenger. Deep, the ocean floor lies nearly 11,000 meters below the surface. To comprehend this depth requires a fundamental shift in perspective. If Mount Everest were placed at the bottom of the Challenger Deep, its peak would still rest over 2 kilometers beneath the surface of the ocean. The pressure at this depth exceeds 1,000 atmospheres, more than 8 tons per square inch. A human body exposed to such pressure would be crushed instantly, compressed into something unrecognizable. For most of human history, the belief persisted that nothing could survive at such depths. The pressure alone seemed incompatible with life. The cold, hovering just above freezing, would slow biological processes to near stillness. The complete absence of light meant no photosynthesis, and without photosynthesis, no food chain. The Mariana Trench, scientists reasoned, must be a dead zone, a lifeless abyss too hostile for even the hardiest microorganisms. This reasoning could not have been more mistaken. The first hint that life existed at these extreme depths came in 1960 when US Navy Lieutenant Don Walsh and Swiss oceanographer Jacques Picard descended to the bottom of the Challenger Deep in the Bathyscaphe Trieste. Their dive, a feat of extraordinary courage and engineering, lasted nearly 9 hours, most of it spent in slow descent through increasingly oppressive darkness. The sphere they occupied was barely large enough for 2 men, the walls thick steel designed to withstand pressures that would crush a submarine like an aluminum can. Outside their small porthole, darkness absolute, the weight of the ocean above them, pressing down with the force of thousands of elephants on every square metre of their vessel. When they finally touched bottom at 10,711 metres, they peered through the small porthole of their vessel into the void, and there, illuminated by their lights, they saw something that should not exist: a flatfish, a creature resembling a flounder, calmly resting on the seabed, as if the crushing pressure and absolute darkness were the most natural conditions in the world. The implications were staggering. If complex multicellular life could exist here, at the very limit of the ocean's depth, then there was no depth barrier to life on Earth. The deep ocean was not a barren wasteland, but a living ecosystem, populated by organisms so uniquely adapted to extreme conditions that they represented entirely different solutions to the challenge of survival. Evolution, it seemed, was far more creative than anyone had imagined. It would be over 50 years before another manned dive reached the Challenger Deep. In 2012, filmmaker James Cameron descended solo in the submersible Deep-Sea Challenger, spending several hours exploring and filming the trench bottom. What he documented was a landscape of fine sediment, scattered rocks, and, remarkably, life. Small amphipods, shrimp-like creatures swarmed around the submersible. Sea cucumbers, primitive but successful organisms, crawled slowly across the mud. Microbial mats covered rocks, processing chemicals in the complete absence of sunlight. The abyss was not empty, it was inhabited. Since then, remotely operated vehicles and landers have been deployed to the trench multiple times, each expedition revealing new species and unexpected complexity. The Hadal Zone, as the deepest parts of the ocean are called, is home to an entire ecosystem that survives on a combination of marine snow, organic detritus that drifts down from the surface like a gentle, constant rain of death, and chemosynthesis, the process by which organisms derive energy from chemical reactions rather than sunlight. But the discoveries in the Mariana Trench are not merely biological, they are geological, chemical, and even, in some disturbing ways, archaeological. The trench is geologically active. The subduction of the Pacific Plate creates volcanic activity, hydrothermal vents, and seismic events. Underwater volcanoes, known as seamounts, rise from the trench floor. Some of these volcanoes are active, spewing superheated water and minerals into the cold darkness. Around these vents, entire communities of life have evolved, organisms that thrive in conditions that would instantly kill most surface life. Tube worms over 2 meters long with no mouth or digestive system survive through symbiotic bacteria in their tissues that process hydrogen sulfide from the vents. Yeti crabs, blind and covered in hair-like setae, farm bacteria on their claws. These are not merely extreme adaptations, these are alternative biologies, life that has evolved in complete isolation from the photosynthetic world. The chemistry of the trench water itself is strange. The pressure forces gases to behave differently. Carbon dioxide remains dissolved rather than forming bubbles. Some compounds that would be solid or gaseous at the surface exist in forms scientists do not fully understand. The water itself is denser, colder, and more saline than surface water, creating distinct layers that act almost like invisible boundaries between different worlds. And then there is the archaeological aspect, though perhaps archaeological is not quite the right word. In 2019, an expedition to the Mariana Trench found something that should not be there: plastic. A plastic bag floating in the Challenger Deep, candy wrappers, microplastics embedded in the tissues of amphipods. Human pollution has reached even here, to the most remote, most inaccessible place on Earth. The ocean, it seems, has no true sanctuary from human activity. But there are other things in the trench, things less easily explained. In various expeditions, researchers have recorded sounds, deep resonant booms that seem to emanate from the trench walls, grinding noises that last for hours, high-pitched squeals that have no apparent biological source. Some of these sounds match known geological phenomena, rock fractures, sediment slides, the grinding of tectonic plates, but others do not match anything in the acoustic database. One sound, recorded in 2016, has been particularly troubling to researchers. It was a series of rhythmic pulses, lasting approximately 40 seconds, descending in frequency. The pattern was regular, almost mechanical, but no known geological or biological process produces such a sound. The recording was made by a hydrophone array at a depth of 18,200 meters. When researchers attempted to locate the source, they found nothing. Just empty water and the distant trench floor below. There are also the lights. Multiple expeditions have reported brief flashes of bioluminescence at depths where no bioluminescent organisms are known to exist. In the Hadal Zone, bioluminescence is rare. Most organisms at these depths are blind, or nearly so, having evolved in complete darkness. There is no evolutionary advantage to producing light when there are no eyes to see it. And yet cameras have captured fleeting glows, greenish-blue flashes that appear and vanish in less than a second. The images are ambiguous. They could be camera artifacts, reflections, or cosmic rays striking the sensor. Or they could be something else. Cameron, during his 2012 dive, reported seeing what he described as a strange shimmer in the water at one point, a distortion that lasted for several seconds before fading. He could not explain it. The cameras mounted on the submersible did not capture it, though they were recording at the time. It was visible only through the porthole, and only to him. When pressed for more detail, Cameron described it as resembling heat haze, the kind seen rising from hot pavement on a summer day, except this was at the bottom of the ocean, where the temperature is barely above freezing. He speculated it might have been a dense plume of cold water mixing with slightly warmer water, creating a refractive boundary. But he did not sound convinced by his own explanation. There are also the biological mysteries. In 2014, a remotely operated vehicle recovered a sample of sediment from the Challenger Deep. When researchers analysed the microbial DNA in the sample, they found genetic sequences that did not match any known organism. The sequences were complete enough to indicate a functioning organism, but they were unlike anything in the genetic database. The organism, whatever it was, had no known relatives. It was as if evolution had taken a completely different path in the trench, producing life forms that shared no common ancestry with surface life. Further analysis suggested the organism was not merely unusual but ancient. The genetic structure indicated an evolutionary lineage that diverged from other life forms hundreds of millions of years ago, perhaps longer. It was, in effect, a living fossil, a relic from a time when Earth's biology was fundamentally different, and it was thriving in the Challenger Deep, untouched by the mass extinctions that had reshaped life on the surface. But what truly unsettles researchers is not what they have found in the Mariana Trench. It is what they have not found. The trench is vast, and exploration has barely scratched the surface. Each expedition covers only a tiny area, a few hundred square meters at most. The vast majority of the trench remains unexplored, unmapped, unknown. The total area of the Hadal Zone worldwide is approximately 45,000 square kilometers, roughly the size of Switzerland, and less than 1% of it has been directly observed by humans or cameras. What lives in the other 99%? What adaptations, what strange biology, what ancient lineages might exist in regions we have never seen? The creatures we have found, the amphipods, the sea cucumbers, the snailfish, these are likely just the most common, the most visible. But the deep sea has taught us that the common is never the whole story. For every organism we see, there are dozens we do not. For every species we identify, there are hundreds that remain hidden. And then there are the maps, or rather, the lack of maps. The Mariana Trench, despite decades of study, remains poorly mapped. The resolution of most seafloor maps is so low that features smaller than 5 kilometers across are invisible. Entire mountains could exist in the trench, and we would not know. Caves, tunnels, structures, all hidden beneath the resolution limit of our instruments. In 2020, a deep-sea mapping expedition used advanced sonar to create a high-resolution map of a small section of the trench. The results were startling. The seafloor was far more complex than previous maps suggested. There were ridges and valleys, steep cliffs and gentle slopes, and most intriguingly, several large depressions in the sediment that appeared circular and evenly spaced, as if arranged in a pattern. The depressions were approximately 30 meters across and 10 meters deep, perfectly circular, with steep sides. Geologists who reviewed the data were puzzled. The depressions did not match any known natural formation. They were too regular, too uniform. One researcher suggested they might be impact craters from meteorites, but the spacing argued against this. Another proposed they were volcanic vents, but there was no evidence of volcanic activity in that region. A third suggested they were created by some unknown biological process, perhaps large organisms burrowing into the sediment, but no organism that size has ever been found in the trench. The mystery remains unsolved. The depressions exist, clearly visible in the sonar data, but their origin is unknown. And because the area is so remote and so deep, there are no plans to send a submersible to investigate further. The cost would be enormous and the scientific return uncertain. So the depressions remain, documented but unexplained, another mystery added to the long list of things we do not understand about the deep ocean. Perhaps the most profound mystery of the Mariana Trench is not what is there, but what it represents. The trench is a reminder of the limits of human knowledge, a monument to the vast unknowns that still exist on our own planet. For all our technology, all our science, all our exploration, we remain profoundly ignorant of the world beneath the waves. The deep ocean is Earth's last true wilderness, a frontier as alien and inaccessible as the surface of another planet. And in that wilderness, in the crushing darkness and numbing cold, in the absolute silence broken only by the occasional groan of shifting rock, there may be things we cannot imagine, forms of life so strange they would challenge our understanding of biology, phenomena so unusual they would rewrite our physics, mysteries so deep they would humble our certainty. The Mariana Trench waits, patient, silent, keeping its secrets in the darkness where light has never reached and may never reach. And perhaps that is as it should be. Perhaps some mysteries are meant to remain unsolved. Perhaps some darkness is meant to stay dark. The image of that vast chasm, deeper than mountains at all, can form in the mind. The weight of the ocean above, the pressure of the depths, the cold that seeps into everything, the silence, profound and absolute, broken only by the slow rain of organic matter falling from above, the faint creaks of the Earth's crust settling, the distant rumble of underwater landslides. This place exists right now, even as eyes close and breathing slows. It exists, unknowable and untouched, a world within our world that remains forever beyond our grasp. The Megalodon question, when extinction becomes doubt. In the warm, shallow seas of the Miocene epoch, approximately 15 million years ago, there swam a creature that would become the stuff of nightmares. Carcharical's megalodon. The megalodon, a shark of such immense proportions that it dwarfed anything alive in our oceans today. The fossil record tells us this much with certainty. Megalodon teeth, massive triangular blades of serrated enamel, have been found on every continent except Antarctica. Some of these teeth measure over 18 centimeters in length, more than 3 times the size of a great white shark's tooth. Based on these teeth and fragments of vertebrae, paleontologists have reconstructed the animal's approximate size. Estimates vary, but the consensus places adult megalodons at 15 to 18 meters in length, with some individuals possibly exceeding 20 meters. The weight of such an animal would have been between 30 and 60 tons. To put this in perspective, a great white shark, the largest predatory shark alive today, reaches a maximum length of about 6 meters. Megalodon was 3 times longer and likely more than 10 times heavier. Its jaws, when fully opened, could have accommodated a standing human being. The bite force has been calculated at somewhere between 108,000 and 180,000 newtons, making it one of the most powerful bites in the history of life on Earth. This was the apex predator of its time. Megalodon fed on whales, seals, sea turtles, and large fish. Bite marks on fossilized whale bones show the characteristic spacing and serration pattern of megalodon teeth, indicating these sharks attacked and fed on animals as large as themselves. They were, by all measures, perfectly adapted to their role as oceanic superpredators, and then, approximately 3.6 million years ago, they vanished. The extinction of megalodon coincides with a period of significant global cooling and changes in ocean circulation patterns. The closure of the Central American Seaway, the formation of the Isthmus of Panama, altered ocean currents and disrupted the distribution of marine species. Many of megalodon's prey species went extinct or migrated to polar regions where the sharks could not follow. Unable to adapt to the changing conditions, megalodon disappeared from the fossil record. This is the accepted scientific narrative. Megalodon is extinct. It has been extinct for millions of years. No credible evidence suggests otherwise. And yet, there are stories, sightings, reports from fishermen, sailors, and divers of enormous sharks, far larger than any great white, encountered in deep water. These reports come from all over the world and span centuries. Most can be dismissed as misidentification, exaggeration, or simple error. A great white shark, seen briefly and under poor conditions, can appear much larger than it actually is. Fear and adrenaline distort perception. Memory is unreliable, but not all reports are so easily dismissed. In 1918, a group of crayfish fishermen in Port Stephens, Australia, refused to go back to sea for several days. They had seen, they claimed, a shark of monstrous size surface near their boat. They described it as being over 30 metres long, with a head as large as the roof of a small house. The fishermen were experienced, familiar with great white sharks, and adamant that what they had seen was something far larger. In the 1960s, a US Navy submarine conducting deep-sea operations off the coast of South Carolina reported sonar contact with what appeared to be an extremely large biological target. The object was tracked for several minutes before it descended beyond the sonar's effective range. The crew estimated its size at over 20 metres. In 2015, footage emerged on social media showing what appeared to be an enormous shark circling a research vessel in the Atlantic. The video quality was poor, and the distance made size estimation difficult. But some marine biologists who reviewed the footage acknowledged that, if genuine, the shark appeared significantly larger than a typical great white. These reports and others like them have fueled persistent speculation that Megalodon might still exist, hidden in the deep ocean where it could avoid detection. The argument, as presented by proponents of the survival theory, goes something like this. The deep ocean is vast and largely unexplored. New species are discovered regularly, including large ones. Giant squid, once thought to be mythical, were confirmed to exist only in recent decades. Coelacanths, prehistoric fish believed extinct for 65 million years, were found alive in 1938. If these animals can survive undetected, why not Megalodon? The deep ocean, they argue, provides ample space for a large predator to exist without frequent surface sightings. Megalodons could have adapted to deep-water hunting, preying on deep-sea fish and squid, rarely needing to enter the shallow coastal waters where they would be seen. The cold temperatures of the deep might have slowed their metabolism, reducing their need for food and allowing smaller populations to persist. It is an appealing narrative. The idea of a living fossil, a monster from the deep past still swimming in the abyss, captures the imagination. It speaks to our desire for mysteries, for unknowns, for the possibility that the world is stranger and more wondrous than we realize. But it is almost certainly wrong. The evidence against Megalodon's survival is overwhelming. First, there is the fossil record. Fossilization is rare, but shark teeth are among the most commonly fossilized structures because sharks shed teeth continuously throughout their lives. A single shark may shed thousands of teeth in its lifetime. If Megalodon still existed, even in small numbers, their teeth would appear in modern sediments. They do not. The youngest Megalodon fossils date to approximately 3.6 million years ago. There is a complete absence of any younger remains. Second, there is the ecological argument. Megalodon was a shallow water predator. Its prey, whales, seals, and large fish, lived in relatively shallow coastal waters. Megalodon's teeth and jaw structure are adapted for hunting large, warm-blooded prey in these environments. The deep ocean, cold and dark, is home to very different animals. Deep-sea fish are small, slow, and energy-poor. There is no evidence that megalodons could have adapted to hunting such prey, and no reason to think they would have needed to. If they could not find food in shallow waters, they would not have survived by moving deeper. Third, there is the problem of population viability. For a species to survive long-term, it requires a minimum population size to maintain genetic diversity and avoid inbreeding. For a large predator like Megalodon, this minimum population would likely be in the thousands. Thousands of 20-metre sharks would require an enormous food supply. The ecological impact of such a population would be visible. There would be bite marks on prey species, strandings of injured animals, sightings, and physical evidence. We see none of this. Fourth, there are the physical constraints. Large sharks like Megalodon must occasionally surface or enter shallow water for various biological reasons, including birthing and possibly thermoregulation. Great white sharks, for instance, are known to travel to specific coastal areas to give birth. If Megalodon still existed, we would expect similar behaviour, and we would see them. The ocean is vast, but it is not so vast that populations of large animals can remain entirely hidden. Whales, even rare species, are regularly spotted and tracked. Megalodons, if they existed, would be seen, yet the reports persist, and not just from unreliable sources or attention seekers. Experienced fishermen, military personnel, marine biologists, people with no obvious reason to fabricate stories, continue to report encounters with sharks that seem impossibly large. These reports are rare, and they're almost never accompanied by clear photographic evidence, but they exist. So what are people seeing? If not megalodons, then what? One possibility is misidentification of known species. Whale sharks, the largest fish in the ocean, can reach lengths of over 12 meters. Basking sharks, the second largest, can exceed 10 meters. Both species are filter feeders, not predators, but from a distance or under poor visibility, they might be mistaken for something more sinister. Great white sharks, while smaller, can appear larger due to perspective and lighting. A 5-meter great white, seen partially and under stressful conditions, might be estimated at twice its actual size. Another possibility is that people are occasionally encountering unusually large individuals of known species. Great white sharks, for instance, typically reach 5 to 6 meters, but there are unconfirmed reports of individuals approaching 7 or even 8 meters. Such outliers would be extremely rare, but not impossible. A 7-meter great white would be genuinely enormous, possibly large enough to be mistaken for something else entirely. There is also the phenomenon of psychological priming. When people expect to see something unusual, they are more likely to interpret ambiguous stimuli as confirming that expectation. A person who believes megalodons might still exist will interpret an encounter with a large shark differently than someone who does not hold that belief. The mind fills in details, exaggerates size, and constructs a narrative that fits the expectation. But none of this fully explains all the reports. Some sightings involve multiple witnesses, experienced observers, and conditions that would make misidentification unlikely. Some describe specific details: the shape of the dorsal fin, the coloration, the movement through the water, that do not match any known species. These reports are rare, but they exist, and they resist easy explanation. Could there be something else in the ocean? Not megalodon, but another large shark species, as yet undiscovered? Marine biologists generally consider this unlikely. Large animals are difficult to hide. They have large ranges. They interact with other species. They leave evidence. The discovery of a new species of large shark would be extraordinary, but not impossible. The ocean is vast and our knowledge of it remains incomplete, or perhaps there is nothing. Perhaps these reports are simply the inevitable result of millions of people spending time on and in the ocean, occasionally seeing things under poor conditions, misinterpreting what they see, and reporting it in good faith. The human brain is pattern-seeking. It constructs narratives from incomplete information. It sees faces in clouds and monsters in shadows. Given enough time and enough observers, a certain number of unusual reports is statistically inevitable, even if nothing unusual is actually occurring. The megalodon question, then, is not really about whether megalodons still exist. They almost certainly do not. The question is about uncertainty, about the limits of knowledge, about the difference between what we can prove and what we can imagine. It is about the tension between our desire for mystery and our need for rational explanation. In the deep places of the ocean, where light fades and pressure increases, where the known gives way to the unknown, it is easy to imagine that anything might be possible, that ancient creatures might persist, hidden and patient, waiting in the darkness. The ocean has kept secrets before. It will keep secrets again, and in that space between certainty and doubt, the imagination finds room to wander. The image of a massive shape moving slowly through dark water can form in the mind. Not threatening, not fearsome, just vast and old and utterly indifferent to the concerns of the surface world. A shadow in the deep, neither confirmed nor denied, existing in that uncertain space where science and imagination meet. The breathing slows. The body relaxes. The mind drifts toward that liminal space where questions dissolve into the gentle darkness of sleep. The underwater formations of Yonaguni, nature or artifact. The tranquil waters near Yonaguni Island, the westernmost point of Japan, have long attracted divers. The island sits in the East China Sea, part of the Ryukyu archipelago, where warm currents from the south meet cooler northern waters, creating an ecosystem rich with marine life. The visibility is exceptional, the coral reefs vibrant, the underwater topography varied and interesting. For recreational divers, it is a paradise. In the spring of 1986, a local dive operator named Kihachiro Aratake was exploring new dive sites south of the island, searching for locations where divers might encounter hammerhead sharks. He descended to approximately 25 meters following the contours of the rocky seafloor. The water was clear, the sunlight filtering down in shimmering columns, and then, emerging from the blue-green twilight, he saw something that stopped him completely. A massive stone structure. Flat terraces stacked upon one another like steps, perpendicular walls meeting at precise angles, what appeared to be carved channels and pathways. The scale was overwhelming, nearly 75 meters long, 25 meters wide, and rising in tiers from the seafloor to within 5 meters of the surface. The stone was covered in a thin layer of algae and coral, but beneath that biological patina, the angles were sharp, the surfaces flat, the edges defined. It looked, unmistakably, like architecture. Aratak surfaced and reported his discovery. Within weeks, other divers had descended to verify the finding. They found not just one structure, but several, scattered across the seafloor south and west of Yonaguni. The largest formation, which came to be known as the Yonaguni Monument, featured multiple terraces, 2 stone pillars approximately 8 meters tall, a flat platform that resembled a plaza or courtyard, and what appeared to be a pathway or road leading from one level to another. Everywhere, there were right angles, parallel lines, and surfaces that seemed too flat, too regular to be natural. The discovery ignited immediate controversy. Was this a natural geological formation, shaped by erosion and tectonic activity, into forms that merely resembled human construction? Or was it evidence of a sophisticated culture that had existed thousands of years ago, now lost beneath the waves? The debate has continued for decades, with passionate advocates on both sides and no consensus in sight. The case for natural formation rests on geology. The Yonaguni Monument is composed of sandstone, a sedimentary rock that forms in horizontal layers. Sandstone is also prone to fracturing along specific planes determined by its internal structure. When subjected to erosion from waves, currents, and tectonic activity, sandstone can break along these planes, creating angular features that appear carved. The island of Yonaguni itself is geologically active, sitting near the boundary of tectonic plates. Earthquakes are common. Uplift and subsidence have occurred repeatedly over millions of years. Geologists who have studied the site point to several features they consider diagnostic of natural formation. The terraces, they note, follow natural bedding planes in the sandstone. The vertical walls align with joint patterns common in this type of rock. Similar formations exist elsewhere in the region, above water, where natural origin is not in question. One such formation, located on the island itself, bears a striking resemblance to the underwater structure. If the terrestrial formation is natural, they argue, the underwater one likely is as well. They also note the absence of certain features that would be expected in human construction. There are no tool marks on the stone surfaces, no evidence of quarrying or deliberate shaping, no artifacts, pottery, tools, building materials in the vicinity, no inscriptions or decorative elements. The structure, for all its apparent precision, lacks the hallmarks of intentional human work. But those who believe the Yonaguni Monument is artificial point to features that seem difficult to explain through natural processes alone. The 2 tall pillars, for instance, stand parallel to each other, approximately 1 meter apart, rising from a flat base. Natural erosion, skeptics argue, does not typically create such symmetrical paired structures. There is also what appears to be a carved face or head, approximately 2 meters wide, with features that some interpret as eyes and a mouth. Pareidolia, the tendency to see faces in random patterns, could explain this, but proponents argue the features are too defined, too deliberate. Perhaps most compelling are the right angles. The monument features numerous places where surfaces meet at what appear to be 90-degree angles. While natural processes can create sharp angles, the consistency and frequency at Yonaguni seem unusual. There are also several features that resemble stairs, with regular riser heights and tread depths, ascending from one terrace to the next. The steps are not perfect, but their regularity is striking. Dr. Masaki Kimura, a marine geologist from the University of the Ryukyus, has spent decades studying the site. He has conducted hundreds of dives, measured and mapped the formations extensively, and published numerous papers arguing for human involvement. Kimura acknowledges that the base structure is natural sandstone, but he believes it was modified and enhanced by human hands. He points to specific features he considers impossible to explain through geology alone: a triangular depression that resembles a pool or tank, channels that seem to direct water flow, and what he interprets as tool marks in certain locations. Kimura also notes the dating implications. If the structure is artificial, it was constructed when the area was above sea level. Sea level rise after the last ice age submerged coastal areas worldwide. The depth and location of the Yonaguni monument suggest it would have been above water approximately 10 to 12,000 years ago, during the end of the Pleistocene epoch. This would make it contemporary with the earliest known monumental architecture in human history, sites like Göbekli Tepe in Turkey, and significantly older than the pyramids of Egypt or the ziggurats of Mesopotamia. The existence of sophisticated stone construction in this region at such an early date would require a significant revision of our understanding of prehistoric Japan. The Jomon culture, which inhabited the Japanese islands from roughly 14,000 BCE to 300 BCE, is known for advanced pottery, but not for monumental stone architecture. If the Yonaguni monument is artificial, it suggests a level of organization and technical skill not previously attributed to Jomon period peoples, or it suggests something else entirely. Some proponents of the artificial theory have linked Yonaguni to the legend of Mu or Lemuria, hypothetical lost continents in the Pacific. These theories, popular in the early 20th century but long since discredited by geology and plate tectonics, proposed that advanced civilizations existed in the Pacific and were destroyed by cataclysm. The Yonaguni monument, in this interpretation, would be a remnant of such a civilization. Most archaeologists and geologists reject these speculations as pseudoscience. There is no geological evidence for lost continents in the Pacific. Plate tectonics explains the configuration of land masses and ocean basins without need for sunken continents, and the leap from "this formation has unusual features" to "this is evidence of a lost civilization" is not supported by any credible data. Yet the formation itself remains, and the debate continues. What is undeniable is that the Yonaguni monument is remarkable. Whether shaped by nature, modified by humans, or constructed entirely by ancient hands, it is a striking feature of the underwater landscape. The terraces rise in tiers, the stone surfaces catch the filtered sunlight, and the overall effect is of something that seems too regular, too purposeful, to be accidental. Divers who visit the site often report a feeling of awe and sometimes unease. The structure is massive and silent, its surfaces covered in the soft growth of algae and coral, small fish darting in and out of crevices. The water temperature is mild, the current usually gentle, but there is something about the place that feels heavy, significant. Whether that feeling comes from the structure itself or from the accumulated weight of speculation and debate is impossible to say. There are other formations in the area, less famous, but no less intriguing. One, located several hundred meters from the main monument, features what appears to be a stone pathway or road, flat and relatively straight, running for approximately 30 meters before disappearing beneath sediment. Another includes a large stone block, roughly cubic, resting on a flat surface in a way that appears balanced and intentional. Yet another shows what might be carved symbols or natural erosion patterns. Interpretations differ depending on the observer's preconceptions. The Japanese government has not designated the site as an archaeological location. Without official recognition as a cultural property, the formations remain largely unprotected and understudied. Academic research has been limited, and much of what has been published appears in obscure journals or popular media rather than peer-reviewed archaeological publications. This has allowed the debate to remain unresolved, with both sides claiming insufficient evidence to conclusively prove the other wrong. In recent years, advanced imaging techniques have been applied to the site. Photogrammetry, which creates three-dimensional models from multiple photographs, has been used to document the monument's features with millimeter-level precision. Sonar mapping has revealed the broader context, showing how the main monument relates to surrounding geological features. But these tools, while providing better data, have not settled the fundamental question. The images are clearer, but the interpretations remain divided. Perhaps the most honest assessment is that we do not know. The Yonaguni monument may be entirely natural, a fortuitous arrangement of geology that happens to resemble architecture. It may be partially natural, with human modification of existing stone formations. Or it may be artificial, a construction from a time before recorded history now claimed by the sea. Without conclusive evidence, artifacts, tool marks, structural elements that cannot be explained by natural processes, the question remains open. And there is something fitting about that. The ocean specializes in ambiguity. It reveals and conceals in equal measure. It offers glimpses of its mysteries but rarely provides complete answers. The Onaguni Monument, whether built by humans or shaped by water and time, stands as a monument to uncertainty itself, a reminder that even when we find something remarkable, understanding what we have found is another matter entirely. The image of those stone terraces descending into deeper water can form in the mind. Sunlight filtering down through clear water, illuminating surfaces that might be natural, might be carved, might be something in between. The silence of the deep, broken only by the gentle sound of bubbles rising from a diver's regulator. The weight of the water, the pressure, the sense of being in a place that exists between what is known and what is imagined. The mind can rest there, in that ambiguous space, neither demanding answers nor fearing their absence. The Baltic Sea Anomaly, Object or Illusion. In the summer of 2011, a Swedish treasure hunting company called Ocean X Team was conducting sonar surveys of the Baltic Sea floor, searching for shipwrecks that might contain valuable cargo. The Baltic is rich with maritime history. Centuries of naval conflicts, merchant trade and passenger travel have littered its floor with thousands of wrecks. For treasure hunters and marine archaeologists alike, it is fertile ground. The team was operating in the northern Baltic, in international waters between Sweden and Finland. The depth in this area ranges from 60 to 90 metres, cold and dark, but well within the capabilities of commercial sonar systems. As they surveyed the seafloor, their sonar detected what appeared to be a wreck. The team marked the location and continued scanning. But when they reviewed the sonar image later, they realised they were looking at something unusual. The object on the seafloor was circular, approximately 60 metres in diameter. It had what appeared to be a raised structure on top, and several features extending from its sides that resembled ramps or ridges. Long drag marks or trenches in the sediment led up to the object, as if it had slid or been pushed across the seafloor before coming to rest. The image was clear enough to show details, but ambiguous enough to invite speculation. The team released the sonar image to the media, describing it as an anomaly, and noting that it did not resemble any known geological formation or man-made structure. The image went viral. Within days, theories proliferated online. It was a crashed UFO. It was a secret Nazi submarine base. It was a naturally formed rock outcrop. It was a hoax. The speculation outpaced the evidence by several orders of magnitude. In 2012, the Ocean X team returned to the site with diving equipment and better sonar. They wanted to see the object firsthand and collect samples. What they found, according to their reports, was both clarifying and confusing. The object was indeed circular and large. It appeared to be composed of stone, covered in sediment and biological growth. The top featured what looked like a flat platform or surface. The sides had features that resembled edges or facets, though whether these were natural or artificial was unclear. The team reported that their electrical equipment malfunctioned when directly above the object. Satellite phones lost signal, cameras shut down without explanation, and some diving lights flickered or failed. These malfunctions ceased when the divers moved away from the object. They collected rock samples from the object's surface and photographed it extensively. The photographs showed a dark, rounded mass covered in silt, with some areas where the underlying stone was visible. The stone appeared to be basalt or a similar volcanic rock, grey-black in colour and fine-grained. The images were suggestive but not definitive. Depending on perspective and lighting, the object either looked like a natural rock formation or something more enigmatic. The rock samples were sent to laboratories for analysis. The results, according to the team, indicated the stone was indeed volcanic, likely basalt. However, some geologists who reviewed the findings noted that basalt is common in the Baltic region due to ancient volcanic activity. The presence of volcanic rock on the seafloor is unremarkable. What would be remarkable is if the rock had been shaped or arranged in a way that suggested intelligence. The samples alone could not answer that question. The electrical malfunctions reported by the team became a focal point for speculation. Skeptics argued that equipment failure underwater is common, particularly with consumer-grade electronics not designed for marine environments. Satellite phones require line of sight to satellites and do not work underwater. And cameras fail for numerous reasons, most of them mundane. The fact that equipment functioned again when divers moved away from the object was consistent with random intermittent failures, not evidence of anything unusual about the object itself. Proponents of the anomaly theory countered that the pattern of failures was too consistent to be coincidental. Multiple devices failing simultaneously and then recovering simultaneously suggested an external influence. They speculated about electromagnetic interference, possibly from metallic components within the object or from unknown sources. Geologists who examined the sonar images and photographs offered a more prosaic explanation. The Baltic seafloor is shaped by glacial activity. During the last ice age, massive glaciers covered the region, carving and scraping the bedrock, transporting enormous boulders and depositing sediment in complex patterns. When the glaciers retreated approximately 10,000 years ago, they left behind a landscape of drumlins, eskers, and glacial erratics, large rocks transported far from their origin and deposited in seemingly random locations. A glacial erratic, they argued, could easily match the description of the Baltic Sea anomaly. Circular or oblong boulders are common. The drag marks could be explained by glacial scraping or by the boulder's movement under the influence of ancient ice flows. The raised features might be natural protrusions, erosion patterns, or areas where harder stone resisted weathering more effectively than surrounding material. This explanation was satisfying to many skeptics, but unsatisfying to others. The object's shape, while not impossible for a natural formation, was unusually regular. The drag marks were long and straight, extending for hundreds of meters, more consistent with something being pushed or pulled than with gradual glacial deposition. And the raised structure on top seemed, to some observers, too defined to be random erosion. The OceanX team has continued to visit the site periodically, releasing new images and videos. Some of these show additional features they interpret as stairs, walls, or openings. Others are less clear, showing only the rocky surface under the limited illumination of dive lights. The team has declined to provide precise coordinates for the site, citing concerns about looters or interference, which has made independent verification difficult. In 2015, a Swedish tabloid published an article claiming that further analysis of the samples revealed unusual metals, including a form of metallic alloy not commonly found in nature. The article suggested this as evidence of artificial construction, possibly even extraterrestrial origin. However, no peer-reviewed scientific publication has confirmed these findings, and when pressed, the laboratories that conducted the analysis have been reluctant to discuss their results in detail. The scientific consensus, to the extent one exists, is that the Baltic Sea anomaly is most likely a natural formation, possibly a glacial erratic, possibly an unusual outcrop of volcanic rock, but not evidence of artificial construction or extraterrestrial visitation. The shape, while interesting, is not impossible for nature to produce. The electrical malfunctions can be explained by known issues with electronics in marine environments. The chemical composition of the samples is consistent with terrestrial volcanic rock. Yet the object remains, and the questions linger. Why is the shape so regular? Why are the drag marks so pronounced? Why has no geologist published a detailed study explaining precisely how such a formation would arise through natural processes? The absence of a thorough scientific investigation has left room for speculation to flourish, and perhaps that is the most significant aspect of the Baltic Sea anomaly. It exists in a space where evidence is insufficient to compel certainty in either direction. It is too ambiguous to prove anything, but too unusual to dismiss entirely. It invites interpretation, and interpretation is shaped by expectation. Those who expect to find mysteries in the ocean see the anomaly as one more piece of evidence that we do not understand our world as well as we think. Those who expect natural explanations see it as an interesting geological formation misinterpreted by overactive imaginations. The ocean floor is vast and largely unmapped. Sonar surveys cover only a fraction of it, and even high-resolution sonar provides only a rough approximation of what lies below. The Baltic Sea alone contains thousands of square kilometers of seafloor that have never been directly observed by human eyes or cameras. In such an environment, finding something unusual is inevitable. The question is always whether unusual means unexplained by current knowledge, or simply not yet explained because no one has looked closely enough. The Baltic Sea anomaly may eventually be explained in detail, its formation process mapped and understood, its mystery resolved. Or it may remain as it is now, an intriguing feature on sonar scans and photographs, interpreted differently by different observers, a Rorschach test of stone and sediment that reveals as much about the observer as about the observed. In the cold, dark waters of the northern Baltic, the object rests, 60 meters across, covered in silt and life, silent and still. Fish swim past it, currents flow around it, and time moves slowly at that depth. The object neither confirms nor denies the theories projected onto it. It simply exists, patient and indifferent, waiting in the darkness for the next diver, the next sonar scan, the next interpretation. The mind can rest with that image. The darkness of deep water, the silence, the cold, a shape in the gloom, neither fully known nor fully unknown. The gentle pressure of the water, the slow rhythm of breathing, the gradual release of questions that have no immediate answers. The body grows heavy, the thoughts drift, and sleep approaches like a slow descent through calm water. The mysterious sounds, Bloop's companions. The bloop, that enigmatic ultra-low frequency sound detected in 1997, is not alone. The ocean is filled with sounds, many of them strange, some of them unexplained. The hydrophone arrays that originally detected the bloop continue to listen, recording the acoustic environment of the deep sea with remarkable fidelity. Over the decades, they have captured numerous other sounds that resist easy classification, each adding another layer to the mystery of what exactly is making noise in the abyss. These sounds have been given names, often whimsical, by the scientists who first detected them. But beneath the playful nomenclature lies genuine puzzlement. Some of these sounds have since been explained, their sources identified through patient investigation. Others remain mysteries. In 1991, the same hydrophone network that would later detect the bloop recorded a sound that came to be known as upsweep. Unlike the bloop, which was a single event lasting approximately 1 minute, upsweep is a continuous sound that persists for hours or even days at a time. It consists of a series of narrow-band upsweeping sounds, each lasting a few seconds and rising in frequency from about 30 Hz to about 60 Hz, then repeating. The sound occurs in seasonal cycles, with increased activity during spring and fall, particularly in the Pacific. The source of upsweep remains uncertain, though the leading hypothesis involves volcanic or hydrothermal activity. The Pacific Ocean floor is geologically active, with numerous underwater volcanoes and hydrothermal vents. As magma moves beneath the crust, or as superheated water escapes through vents, it creates pressure waves that propagate through the water. These waves can produce complex acoustic signatures, including upsweeping tones. The seasonal variation might correlate with changes in ocean temperature or pressure that affect how these sounds propagate. But not everyone is convinced by this explanation. The regularity of the sounds and their persistence over decades seem unusual for volcanic activity, which tends to be more chaotic and episodic. Some researchers have suggested that upsweep might be generated by some form of resonance in underwater caves or canyons, where water flowing through specific geometries creates standing waves that produce audible frequencies. This remains speculative. Another sound, recorded multiple times between 1997 and 2007, was named slow down. As the name suggests, slow down is characterized by a long, descending tone that lasts up to 7 minutes. The sound begins at a high frequency and gradually decreases like a long, drawn-out sigh. The source location, based on triangulation from multiple hydrophones, places it somewhere in the southern Pacific, but no specific origin has been identified. The acoustic characteristics of slowdown suggest something large and moving. When objects move through water at high speed, they create sounds with specific patterns related to their velocity and size. The descending tone of slow down is consistent with something large decelerating, or perhaps with an object moving away from the hydrophones at decreasing speed. But no known marine animal or geological process matches this signature precisely. Ice has been proposed as the source. Large icebergs, as they melt and fracture, produce a variety of sounds. When an iceberg cracks and large pieces carve off, the sudden release of stress creates intense acoustic energy. When ice scrapes against the seafloor or against other ice, it produces grinding noises, and when ice melts, releasing trapped air bubbles, it creates a fizzing or crackling sound. Some of these ice-related sounds might, under certain conditions, produce tones that resemble slow down. The seasonal timing supports this theory. Slow down is most frequently detected during the Antarctic spring and summer, when ice melting is most active. The location, in the southern Pacific, is consistent with drift patterns of Antarctic icebergs. However, the specific mechanism by which ice would produce such a long, continuous descending tone remains unclear. Most ice-related sounds are shorter and more chaotic. Then there is Julia, recorded in March 1999. Julia is a brief sound lasting approximately 15 seconds, but it is loud enough to have been detected by hydrophones separated by over 5,000 kilometers. The sound structure is complex, beginning with a low-frequency rumble and then developing into a series of rapid oscillations before fading. Triangulation placed the source near the southwestern Pacific, in a region close to Antarctica. Julia's acoustic signature is particularly intriguing because it shares some characteristics with biological sounds. The rapid oscillations resemble, in structure if not in scale, the vocalizations of certain marine mammals. But the amplitude, the sheer loudness of the sound, suggests a source far larger than any known animal. If Julia was produced by a living organism, it would need to be enormous, far larger than a blue whale, and possess vocal capabilities unlike anything currently known to biology. The official explanation for Julia, offered by NOAA, is that it was caused by a large iceberg scraping across the seafloor. This is plausible. The location is consistent with iceberg drift patterns, and the grinding of ice on rock can produce loud, complex sounds. However, the brief duration and the oscillating structure seem unusual for ice scraping, which typically produces more sustained grinding noises. The mystery has not been entirely resolved. Another sound, train, was recorded in 1997 and resembles, as the name suggests, the sound of a train on distant tracks. It is a low-frequency rumble that persists for several minutes, with a rhythm that sounds almost mechanical. The source has never been identified. Volcanic activity is the leading hypothesis, but the regular rhythm is difficult to explain through chaotic geological processes. Perhaps the most unsettling sound is whistle, a very brief, high-pitched tone that has been recorded sporadically since the early 1990s. Unlike the other sounds, which are detectable across vast distances, whistle is relatively local, picked up by only one or two nearby hydrophones. The sound lasts less than a second and has a pure, almost synthetic quality. It does not match any known marine animal vocalization. It does not match known geological sounds. And it appears in locations scattered across different ocean basins with no apparent pattern. Some researchers have suggested that whistle might be produced by human activity, submarines, research equipment, or military installations. However, the frequency and timing of the detections do not correlate with known human operations. The sound occurs at random intervals, sometimes months or years apart, in regions where human activity is minimal. The mystery persists. There are also sounds that have been explained, but only after years of investigation. In 1997, a sound called slow sweep was recorded, similar to upsweep but with a slower rate of frequency change. For years, the source was unknown. Eventually, researchers determined that slow sweep was likely produced by volcanic activity at the mid-Atlantic ridge, where tectonic plates are spreading apart and magma rises from the mantle. The sound is created by the movement of magma and the release of gases through underwater vents. The regularity comes from the geometry of the vent system, which creates resonances that produce specific frequencies. Another sound, bowing, sounds exactly as its name suggests, a series of brief, springy noises, like a cartoon sound effect. Bowing was eventually identified as the call of a minke whale, a species that produces vocalizations unlike those of other whales. The unusual structure of the sound had initially made identification difficult, but repeated detections and correlation with whale sightings eventually solved the mystery. These successes demonstrate that many mysterious ocean sounds do have prosaic explanations, often involving either ice or marine life. But they also demonstrate that identifying the source requires extensive investigation, careful analysis, and often a bit of luck. The ocean is vast, the sounds are brief and infrequent, and the conditions that produce them are often unique and difficult to replicate. What makes the remaining unexplained sounds particularly intriguing is not just that they resist explanation, but that they occur at all. The deep ocean is the most stable environment on Earth. Temperatures vary by only a few degrees, salinity is nearly constant, currents are slow and predictable. This stability means that any sound is likely to be either biological, geological, or anthropogenic. There are not many other options, and yet some sounds do not fit neatly into any of these categories. Could there be sources of sound we have not considered? Some researchers have speculated about exotic possibilities. Turbulence in deep ocean currents might, under specific conditions, create acoustic phenomena we do not yet understand. Large-scale underwater landslides, while rare, can produce enormous sounds. Methane clathrates, frozen deposits of methane gas buried in seafloor sediment, occasionally release gas in explosive events that create loud acoustic signatures. Each of these possibilities has been invoked to explain one or another of the mysterious sounds, but none provides a comprehensive explanation. There is also the question of what we might be missing. Hydrophones are sensitive instruments, but they have limits. They detect only sounds within specific frequency ranges. Sounds that are too high-pitched or too low-pitched may go undetected. They're also limited by their geographic distribution. Vast areas of the ocean are not monitored by any hydrophones. A sound occurring in an unmonitored region would never be detected, regardless of its volume or strangeness. This raises an uncomfortable question. How many other sounds are occurring in the ocean that we never hear? How much acoustic activity exists beyond the range of our instruments or in locations we do not monitor? The sounds we have recorded, the bloop, upsweep, Julia, and the others, may represent only a small sample of a much larger and more complex acoustic environment that remains hidden from us. The ocean speaks, constantly and in many voices. Most of what it says is mundane, the calls of whales, the grinding of ice, the rumble of the Earth's crust. But occasionally it says something unexpected, something that makes scientists pause and wonder what, exactly, is down there making that noise. The mind can rest with this thought. The ocean, vast and dark, filled with sounds that echo through the abyss. Calls and groans, whistles and booms, a symphony of the deep that plays continuously, heard by no one except sensitive instruments, recording in silence. The body relaxes, the breathing slows, and consciousness drifts toward the same quiet depths where these sounds originate, fading into the gentle static of sleep. The ghost ship, Octavius, frozen in time. The tale of the Octavius is one of the most enduring and unsettling stories in maritime history. Whether it is entirely true, partially true, or wholly invented remains unclear, but the narrative has persisted for over 2 centuries, passed down through generations of sailors and maritime historians, always with the same combination of fascination and dread. The year was 1775. The whaling ship Herald was navigating through treacherous waters near Greenland, threading carefully between massive ice floes, when the lookout spotted something unusual. A ship, apparently adrift, its sails tattered and grey with ice. No movement on deck, no response to signals. The vessel appeared abandoned, but it was still afloat, drifting with the current. Captain Warren of the Herald ordered a crew assembled to board the mystery ship and investigate. As they drew closer, they could read the name painted on the hull, Octavius. The ship was a merchant vessel, a square-rigged 3-master of English design, built for cargo transport across long ocean routes. But it was not the ship's design that disturbed the approaching crew, it was the state of the vessel. Ice encrusted every surface. The rigging was frozen solid, and despite being afloat, the ship had the appearance of something that had been abandoned for a very long time. The boarding party climbed onto the deck, their boots crunching on frost. The silence was absolute. No creaking of timbers, no sound of wind in the rigging, nothing. The deck was covered in a thick layer of ice and snow. The hatches were all closed. And there was no sign of life. They descended into the ship's interior, and what they found there has become the stuff of maritime legend. In the captain's cabin, they discovered the captain himself, still seated at his desk, frozen solid. A quill pen was still in his hand, as if he had been writing and simply stopped mid-sentence. Papers were scattered across the desk, also frozen. The captain's face, preserved by the extreme cold, showed an expression of calm concentration, as if he had died without realizing death was approaching. Near him, also frozen, was a woman, presumably his wife, wrapped in blankets, and a small child, likewise preserved by the cold. Elsewhere in the ship, the boarding party found more frozen crew members. One sailor was frozen in his hammock, a blanket pulled up to his chin. Another was found in the galley, a piece of food still in his hand. A third was discovered on deck, partially buried in snow, apparently having died while attempting to adjust the sails. Each body was perfectly preserved, frozen in the position of death, creating a tableau of a ship caught in the moment of its doom. The logbook was recovered from the captain's cabin. According to the entries, the Octavius had left England in 1761, bound for China. The ship had completed its voyage, loaded cargo, and begun the return journey. But rather than sailing south around the Cape of Good Hope or Cape Horn, the captain had decided to attempt the Northwest Passage, the fabled northern route through the Arctic that promised to cut months off the journey if successfully navigated. This was, even by the standards of the 18th century, an extraordinarily risky decision. The Northwest Passage was known to be choked with ice, passable only during brief periods in summer, and even then fraught with danger. Ships that attempted it often became trapped in ice floes and crushed. The few that succeeded had done so with great luck and at great risk, but the potential rewards, a faster route, lower costs, competitive advantage, apparently motivated the captain to try. The log entries became increasingly desperate as the ship pushed farther north. Ice closed in, temperatures dropped, progress slowed. By November 1762, the ship was completely frozen in place, trapped in pack ice north of Alaska. The crew attempted to free the ship, but the ice was too thick. They were stuck. The final entry in the log, dated November 11, 1762, was brief and matter-of-fact. "We have been trapped in ice for 17 days. The men are cold. We cannot get free." If the log is to be believed, the Octavius had been trapped in ice for 13 years before being discovered by the Herald in 1775. During that time, it had drifted slowly through the Arctic waters, carried by currents, eventually emerging from the ice and continuing its drift south into the Atlantic. The crew had frozen to death, likely within weeks of becoming trapped, and the ship had continued its journey as a ghost, crewless and silent, a floating tomb encased in ice. The crew of the Herald, understandably disturbed by what they had found, took the logbook and quickly returned to their own ship. They did not attempt to salvage the Octavius or recover the bodies. According to the account, Captain Warren decided the ghost ship was too dangerous to tow. Superstition ran strong among sailors, and a ship full of frozen dead was considered deeply unlucky. The Herald sailed away, leaving the Octavius to continue its drift. The ship was never seen again. No further sightings were recorded, no wreckage recovered. It presumably sank eventually, the ice-damaged hull finally giving way, sending the frozen crew and their ship to the ocean floor. This is the story as it has been told and retold. But is it true? There are reasons to be skeptical. The tale first appeared in print decades after the alleged events, and no contemporary account from the crew of the Herald has ever been found. No official record of the Octavius exists in English maritime archives. No ship by that name is listed as having departed England for China in 1761. The logbook, supposedly recovered from the ship, has never been produced for verification. The entire story may be a fabrication, a maritime legend invented to entertain or to serve as a cautionary tale about the dangers of Arctic navigation. Yet elements of the story have the ring of truth. Ships did attempt the Northwest Passage during this period, driven by the promise of shorter routes and commercial advantage. Many did become trapped in ice and were never seen again. The Franklin expedition of 1845, for instance, lost 2 ships and 129 men in an attempt to chart the passage. The ships, HMS Erebus and Terror, were trapped in ice and eventually abandoned. The crews died attempting to walk to safety across the Arctic. The wrecks were not found until 2014 and 2016, over 160 years after they were lost. If the Franklin expedition could vanish so completely, leaving only scattered artifacts and fragmentary accounts from Inuit witnesses, then the Octavius, if it existed, could certainly have been lost without trace. The Arctic is vast and unforgiving. Ships caught in ice are often crushed and sunk, leaving little evidence. Those that remain afloat can drift for years, carried by currents through regions where no other ships travel. There are also documented cases of ghost ships found drifting, their crews dead or vanished. The Mary Celeste, discovered in 1872, was found abandoned in the Atlantic with no sign of the crew and no clear explanation for their disappearance. The ship's cargo was intact, the crew's belongings undisturbed, and the lifeboat missing, suggesting a sudden but orderly abandonment. But why the crew left and what happened to them has never been satisfactorily explained. The Octavius story, whether true or apocryphal, speaks to deeper anxieties about the sea and about the Arctic in particular. The image of a ship frozen in time, its crew preserved in death, drifting silently through icy waters, is profoundly unsettling. It suggests the ocean as a kind of limbo, a place where the normal passage of time is suspended, where the boundary between life and death becomes uncertain. In the Arctic, these anxieties are amplified. The extreme cold preserves bodies indefinitely. Explorers who died in the 19th century have been found in recent decades, their bodies almost perfectly preserved, their clothing intact, their final expressions frozen on their faces. Time moves differently in the cold. Decay slows to a crawl. The dead do not return to the earth but remain, suspended, waiting in the ice. The ocean holds these frozen dead in its northern reaches, ships, crews, explorers, all claimed by the ice and held in stasis. Some are eventually released, drifting south as the ice melts, emerging into warmer waters as ghost ships, bearing their silent cargo of the preserved dead. Others remain locked in ice, entombed, waiting for the day when warming temperatures might free them. Climate change is, in fact, revealing these lost ships and lost explorers. As Arctic ice melts at unprecedented rates, regions that have been frozen for centuries are opening. Wrecks that were once inaccessible are now exposed. Bodies that were buried in ice are emerging. The Arctic is giving up its dead. Whether the Octavius ever existed is perhaps less important than what it represents. It is a symbol of the ocean's power to preserve and to hide, to take ships and crews and hold them in suspension, neither fully lost nor fully found. It reminds us that the ocean, particularly in its coldest and most remote regions, operates by rules different from those of the surface world. Time, decay, discovery, all work differently when water turns to ice and ships become tombs. The image of the frozen captain, still at his desk, pen in hand, can form in the mind. The absolute stillness of the cabin, the frost on every surface, the silence. Outside, the ship drifts slowly through cold water, its passage making no sound. Inside, time has stopped. The captain writes his final entry, the ink freezes on the page, and he remains there, in that moment, forever. The breathing slows, the body relaxes, the mind drifts toward that same stillness, that same suspension between one moment and the next. The milky seas, oceans of light. In January 1995, the British merchant vessel SS Lima was sailing through the Indian Ocean, southwest of the Horn of Africa. It was night, and the sea was calm. The crew was engaged in routine navigation, the ship cutting steadily through dark water under a sky brilliant with stars. And then, around midnight, the ocean began to glow. At first, the crew thought they were seeing bioluminescence, the natural light produced by certain marine organisms when disturbed. Bioluminescence is common in many parts of the ocean. Dinoflagellates, tiny plankton, emit flashes of blue-green light when agitated by waves or by the passage of a ship. The effect is beautiful, trails of glowing water following the ship's wake. The occasional bright flash as a fish moves through the glowing plankton. Sailors have witnessed this phenomenon for centuries, but what the crew of the Lima saw was different. The glow was not localized to their wake. It extended in every direction as far as the eye could see. The entire ocean surface was luminous, glowing with a steady, uniform white light. It was as if the ship was sailing across a sea of milk or across clouds lit from below. The stars were visible above, the glowing sea below, and the horizon dissolved into an indistinct boundary where sea and sky merged in pale luminescence. The crew gathered on deck, stunned. Some found the sight beautiful, others were unsettled. There was something uncanny about it, something that violated the expected order of things. The ocean should be dark at night. Instead, it glowed with soft, even light that had no apparent source and no clear explanation. The phenomenon lasted for over 6 hours. The ship travelled more than 250 kilometres during that time, and the glowing sea extended the entire distance. When dawn finally broke, the glow faded, and the ocean returned to its normal appearance. Dark blue water, nothing unusual, as if the night's events had been a collective hallucination. But they were not hallucination. The crew logged the event, noting the coordinates, duration and extent of the phenomenon. When the lemur reached port, the story spread, and researchers, upon hearing it, recognised the description immediately. What the crew had witnessed was a milky sea, one of the rarest and most mysterious phenomena in oceanography. Milky seas have been reported for centuries. Sailors in the Arabian Sea, the Indian Ocean, and occasionally other regions have described nights when the ocean glows with diffuse, steady light over vast areas. The earliest recorded account dates to 1854, when the clipper ship Shooting Star encountered glowing seas in the Indian Ocean. The captain wrote, "The whole appearance of the ocean was like a plain covered with snow or a sheet of unbroken ice." More accounts followed. In 1887, the ship Leander reported sailing through glowing seas for over 3 hours. In 1915, the Danish steamship Cora encountered glowing waters covering an estimated 15,000 square kilometres. In each case, the descriptions were similar: uniform, diffuse white or pale blue light covering enormous areas, lasting hours, with no localised bright spots or flashing. For most of history, these reports were treated as curiosities, interesting but unverifiable. The scientific community acknowledged that bioluminescence existed, but the scale and nature of milky seas seemed implausible. How could bioluminescent organisms produce such uniform, steady light over such enormous areas? Bioluminescence is typically a response to disturbance, waves, predators, motion. But milky seas glow steadily, regardless of water movement. The mechanism did not make sense. Then, in 2005, researchers at the Naval Research Laboratory announced they had detected a milky sea from space. Using satellite imagery from the Defense Meteorological Satellite Program, they had identified an area in the Indian Ocean, approximately 15,000 square kilometres in extent, that was glowing brightly enough to be visible from orbit. The glow was steady and diffuse, not the sharp flashes of typical bioluminescence. It persisted for 3 consecutive nights before fading. The satellite detection confirmed that milky seas were real and that their scale was even larger than historical accounts suggested. An area the size of Connecticut glowing with enough intensity to be visible from space. This was not a minor phenomenon. It was something significant, something that required a biological or chemical process operating on a massive scale. But what process? The leading hypothesis involves bacteria, specifically bioluminescent bacteria of the genus Vibrio. These bacteria are common in marine environments and are known to produce light through a chemical reaction involving luciferase enzymes. Under normal conditions, individual bacteria produce only faint light, insufficient to be visible. But when bacteria reach high enough concentrations, a phenomenon called quorum sensing, they can coordinate their light production, creating visible bioluminescence. For a milky sea to form, bacteria would need to reach extraordinary densities over enormous areas. Researchers have calculated that bacterial concentrations would need to exceed 10⁹ cells per litre, a billion bacteria in every litre of water. The surface layer of the ocean, potentially hundreds of metres deep, would need to be saturated with these bacteria. They would need to remain concentrated in that area for hours or days, glowing steadily before dispersing or dying. What could cause such a bacterial bloom? One possibility is nutrient upwelling. In certain regions, deep ocean currents bring nutrient-rich water to the surface. This sudden influx of nutrients can trigger explosive growth in bacterial populations. If conditions are right, temperature, salinity, available nutrients, the bacteria can multiply rapidly, reaching the densities necessary to produce visible light. Another possibility involves dead or dying organisms. When large numbers of fish or other marine animals die, they release organic matter into the water. Bacteria feed on this organic matter, multiplying quickly. In some cases, the bacterial bloom is so intense that it depletes oxygen in the water, creating dead zones where other life cannot survive. If the bacteria involved a bioluminescent species, the bloom might produce a milky sea. Both explanations are plausible, but neither has been definitively confirmed. The challenge is that milky seas are rare, unpredictable, and occur in remote ocean regions where research vessels are seldom present. By the time scientists learn of a milky sea, it has usually dissipated. Water samples taken days or weeks later show no unusual bacterial concentrations. The bloom, whatever caused it, is gone. There is also the question of why milky seas occur predominantly in the Indian Ocean and Arabian Sea. These regions are not obviously different from other tropical and subtropical oceans. They have similar temperatures, similar nutrient cycles, similar marine life. Yet milky seas in other regions are exceedingly rare. A few have been reported in the Atlantic and 1 or 2 in the Pacific, but the vast majority occur in the Indian Ocean. Why this geographic concentration remains unclear. Some researchers have speculated about other contributing factors. The Indian Ocean has unique current patterns, including the monsoon-driven reversing currents that change direction seasonally. These currents might create conditions that concentrate bacteria in specific areas. The region also has extensive areas of low oxygen in the deeper waters, which might influence bacterial growth at the surface. But these remain speculations. There is also the subjective experience of witnessing a milky sea. The accounts from sailors often include emotional reactions that go beyond simple observation. The phenomenon is described as eerie, otherworldly, beautiful but unsettling. Several captains have noted that crew members became anxious or superstitious when sailing through glowing seas, interpreting the light as an omen or a sign of something unnatural. This emotional response might seem irrational, but it reflects something deeper about human psychology. We expect the ocean to be dark at night. Darkness is the natural state of the nighttime sea. When that expectation is violated, when the ocean glows without apparent cause, it triggers a sense of wrongness, a feeling that the rules of nature have been suspended. The mind struggles to reconcile the visual input with its understanding of how the world should work. In some accounts, sailors report that the glowing sea made navigation difficult. The usual contrast between dark water and lighter sky was reversed, making it hard to judge distance or perceive the horizon. Stars reflected in the glowing water, creating visual confusion. Some captains reported slowing their vessels or altering course, not because of physical danger, but because the disorientation made them uneasy. The phenomenon also raises questions about what else might be glowing in the ocean, unseen and unrecorded. Milky seas occur at the surface and are visible from ships or satellites. But what about bioluminescent events in deeper water, where no light reaches the surface? What about deep ocean bacterial blooms that glow in the abyss, far below where any instrument might detect them? The deep ocean is full of bioluminescent life. Fish with glowing lures, squid that emit ink clouds of luminescent fluid, jellyfish that pulse with light. In the darkness of the deep sea, bioluminescence is the primary form of visual communication. Creatures use light to attract prey, to signal to mates, to startle predators, to camouflage themselves against the faint light filtering from above. The deep sea is not dark, not really. It is alive with light, a constant flickering and glowing in the blackness. Could there be milky seas in the deep? Vast volumes of water, hundreds or thousands of meters below the surface, glowing with bacterial light. Such events would be invisible from above, undetectable by satellites, and rarely encountered by the few submersibles that venture to those depths. They could be common, occurring regularly in the deep ocean, and we would never know. The ocean holds light within its darkness. Not the light of the sun, which fades to nothing within 200 meters of the surface, but the light of life itself, the glow of organisms that have evolved to create their own illumination. In the deepest trenches, where pressure is crushing and no hint of daylight has ever penetrated, there is still light. Faint, flickering, transient, but present. The ocean is never entirely dark. The image of a glowing sea stretching to the horizon in every direction can rest in the mind. Soft white light, uniform and gentle, neither bright nor dim but somewhere in between. The ship moving through it like a shadow, the glow undisturbed by its passage. Above, the stars. Below, the luminous water. And in between, the sense of being suspended between two skies, two lights, neither fully of the day nor of the night. The breathing deepens, the body stills, the mind drifts toward that luminous space, that in-between place where questions dissolve into gentle light. The Bermuda Triangle, legend and reality. The Bermuda Triangle, also known as the Devil's Triangle, is perhaps the most famous region of ocean on Earth. Its boundaries are loosely defined, typically described as the area between Miami, Bermuda and Puerto Rico, roughly 500,000 square miles of the western Atlantic Ocean. Within this region, according to popular legend, ships and aircraft have vanished without trace, defying explanation and generating decades of speculation about mysterious forces, unusual phenomena, and even paranormal activity. The modern mythology of the Bermuda Triangle began in 1950 with an article by journalist Edward Van Winkle Jones, who noted a number of unexplained disappearances in the region. The idea was expanded in 1964 by writer Vincent Gaddis, who coined the term Bermuda Triangle in an article for Argosy magazine. But it was Charles Berlitz's 1974 book, The Bermuda Triangle, that truly captured public imagination and cemented the region's reputation as a place of mystery and danger. Berlitz catalogued dozens of incidents: ships found abandoned, aircraft disappearing from radar, entire crews vanishing without distress signals. He suggested various explanations, from magnetic anomalies to time warps to extraterrestrial abduction. The book was a massive bestseller, and the Bermuda Triangle entered popular culture as a place where the normal laws of physics and probability seemed not to apply. But does the evidence support this reputation? Are disappearances in the Bermuda Triangle truly unusual, or is the legend built on selective reporting, exaggeration, and misunderstanding? The most famous incident associated with the Bermuda Triangle is Flight 19. On December 5, 1945, 5 US Navy Avenger torpedo bombers took off from Fort Lauderdale, Florida, for a routine training exercise. The flight was led by Lieutenant Charles Taylor, an experienced pilot. The mission was straightforward: fly east for a specified distance, conduct practice bombing runs, and return to base. Approximately 90 minutes into the flight, radio transmissions indicated that Taylor believed they were lost. He reported that his compasses were malfunctioning and that he could not determine their position. The transmissions became increasingly confused. Taylor seemed to believe they were over the Florida Keys, far south of their actual position, and he ordered the flight to head northeast, which would have taken them farther out to sea if they were in fact north of the Keys. Communication with the flight became intermittent. Weather was deteriorating and fuel was running low. The last transmission from Flight 19 was received around 7 p.m. The 5 aircraft and their 14 crew members were never seen again. A search and rescue operation was launched immediately. One of the search planes, a PBM Mariner flying boat, also disappeared, along with its crew of 13. No wreckage from Flight 19 or the Mariner was ever found. The disappearance of 6 aircraft and 27 men in a single day, with no trace, became one of the most enduring mysteries in aviation history. Official investigations concluded that Taylor had become disoriented, possibly due to compass malfunction, and had led the flight out over the Atlantic until they ran out of fuel and ditched in the ocean. The Mariner was known to be prone to fuel leaks and may have exploded in flight, a common hazard with that aircraft type. The lack of wreckage was attributed to the deep water and strong currents in the area, which would have dispersed debris widely. This explanation is plausible, but it leaves questions. Why did the compasses malfunction? Why were no distress signals received from the aircraft as they went down? Why was no debris ever found despite extensive searches? Proponents of the Bermuda Triangle mystery point to these unanswered questions as evidence of something unusual. Skeptics counter that the Atlantic is vast, deep and unforgiving. Aircraft that ditch in rough seas break apart and sink quickly. Debris disperses. And this was 1945, before modern emergency beacons and satellite tracking. Losing aircraft at sea, even with extensive searches, was not uncommon. Other disappearances in the Bermuda Triangle have similarly ambiguous explanations. The USS Cyclops, a Navy cargo ship, vanished in March 1918 with 306 crew and passengers aboard. The ship was travelling from Barbados to Baltimore and never arrived. No distress signal was sent, no wreckage was found. The disappearance remains the single largest loss of life in US naval history not directly involving combat. The official explanation is that the Cyclops was overloaded, structurally unsound, and encountered a sudden storm. The ship may have broken apart and sunk rapidly, giving the crew no time to send a distress signal, but again, the complete absence of wreckage or survivors is unusual. More recently, smaller vessels have disappeared in the region. Pleasure boats, fishing vessels, and small aircraft vanish each year in the Western Atlantic, some within the boundaries of the Bermuda Triangle. In most cases, wreckage is eventually found, or weather conditions at the time of disappearance provide a clear explanation. But occasionally, vessels disappear without trace, leaving only unanswered questions. The statistical argument against the Bermuda Triangle mystery is straightforward. The region is one of the busiest shipping lanes in the world. Hundreds of thousands of vessels pass through each year. It is also prone to severe weather, including hurricanes and sudden storms. The Gulf Stream, a powerful ocean current, runs through the region, creating complex and sometimes treacherous sea conditions. Given the volume of traffic and the environmental hazards, a certain number of accidents and disappearances is statistically inevitable. Multiple studies have examined whether the rate of disappearances in the Bermuda Triangle is higher than in other comparable regions of ocean. The consensus is that it is not. When adjusted for the volume of traffic, the Bermuda Triangle has no more incidents than any other heavily travelled ocean region. The legend, according to this analysis, is just that, a legend built on selective attention to incidents that occur in a specific geographic area, and ignoring the fact that similar incidents occur everywhere. But proponents of the mystery are not easily dissuaded. They point to specific features of the region that might contribute to unusual phenomena. The Bermuda Triangle sits atop significant deposits of methane hydrates, frozen methane gas trapped in seafloor sediment. If these deposits are destabilized, they can release large bubbles of methane gas into the water. A ship caught in such a bubble would lose buoyancy and sink rapidly. The methane might also rise into the atmosphere, where it could affect aircraft engines or create sudden downdrafts. This hypothesis has some scientific support. Laboratory experiments have shown that large bubbles rising through water can indeed reduce buoyancy dramatically, and methane releases from seafloor deposits do occur, occasionally violently. However, there is no direct evidence linking methane releases to any specific disappearance in the Bermuda Triangle. The theory remains speculative. Another proposed explanation involves magnetic anomalies. The Bermuda Triangle is one of the few places on Earth where true north and magnetic north align, a phenomenon that can cause compass errors. If pilots or navigators are not aware of this alignment, they might misinterpret compass readings and become disoriented. This could explain the compass problems reported by Lieutenant Taylor during the Flight 19 incident. But magnetic variation is well understood and accounted for in navigation. Modern GPS systems do not rely on magnetic compasses, and even in 1945, naval aviators were trained to deal with magnetic variation. It seems unlikely that magnetic anomalies alone could account for the number of incidents attributed to the region. There are also environmental factors unique to the area. The Gulf Stream creates unpredictable currents and eddies. Weather can change rapidly, with calm seas giving way to violent storms in minutes. The region is also prone to waterspouts, tornadoes that form over water, which can pose serious hazards to small vessels and low-flying aircraft. Shallow reefs and shoals, remnants of ancient coral formations, create navigation hazards that have claimed ships for centuries. When all these factors are considered, heavy traffic, severe weather, strong currents, magnetic variations, and geological features, the Bermuda Triangle begins to look less like a place of mystery and more like a region where natural hazards are concentrated and well documented. The disappearances, rather than being inexplicable, become explicable as the inevitable result of humans operating vehicles in a challenging environment. Yet the legend persists. Part of the appeal is psychological. Humans are pattern-seeking creatures. We look for meaning in randomness, for connections between unrelated events. The Bermuda Triangle provides a geographic focus for this tendency. Disappearances that occur within its boundaries are seen as connected, part of a larger pattern, even when they may be entirely independent events with unrelated causes. There is also the appeal of mystery itself, the idea that there are places in the world where strange forces operate, where the rational explanations fail, where the unknown still holds sway. This is compelling. It suggests that despite our science and technology, despite our maps and instruments, the world remains fundamentally mysterious, and for some that is a comforting thought. The ocean encourages this kind of thinking. It is vast, deep, and largely unknown. Ships disappear, aircraft vanish, and sometimes no trace is ever found. The ocean keeps its secrets. Whether those secrets are simply the mundane result of natural hazards and human error, or whether they hint at something stranger, depends largely on what one wants to believe. The Bermuda Triangle, then, is less a place than an idea that the world is more mysterious than it appears, an idea that there are regions where normal rules do not apply, an idea that disappearance and loss, rather than being explicable tragedies, are instead hints of deeper mysteries. And perhaps that is enough. Perhaps the Bermuda Triangle serves a purpose, not as a source of genuine scientific mystery, but as a focus for human imagination, a reminder that the ocean is vast and powerful, and that we, for all our cleverness, are still small and vulnerable when we venture out upon it. The image of a ship sailing through calm waters, the horizon clear, the sky blue, and then simply vanishing, leaving no trace, can rest in the mind. Not threatening, not fearsome, just the quiet acknowledgement that disappearance is possible, that the ocean can claim what it wishes, and that sometimes there are no answers, only absence. The breathing slows. The mind accepts the mystery without needing to solve it. And in that acceptance there is a kind of peace. The deep scattering layer, the ocean's phantom bottom. During World War II, naval forces on all sides relied heavily on sonar to detect submarines. Sonar, sound navigation and ranging, works by emitting pulses of sound into the water and listening for echoes. When the sound wave encounters something solid, a submarine, a ship, the ocean floor, it bounces back, and the time it takes for the echo to return indicates the distance to the object. For submersible pilots and deep-sea researchers, encountering the deep scattering layer is an unforgettable experience. Descending through the water column during the day, the submersible passes through relatively empty water. Blue, clear, featureless. Then, at a certain depth, the water suddenly fills with life. Lanternfish dart past the viewport, their bodies flashing with bioluminescent spots. Translucent squid hover in the beam of the submersible's lights, their internal organs visible through their transparent skin. Jellyfish pulse slowly through the water, trailing long tentacles. Crustaceans with enormous eyes and delicate legs drift in the current. The concentration is astonishing. In some areas, the biomass is so dense that visibility drops to just a few meters. The submersible's lights illuminate a swirling cloud of the life, organisms of every size and shape, all suspended in the same layer of water, all participating in the same ancient pattern of movement. And then, as the submersible descends deeper below the layer the water empties again, the life vanishes. The deep ocean below the DSL is relatively barren, with only occasional solitary fish or drifting jellyfish breaking the emptiness. The contrast is stark, a zone of intense life suspended above a vast, quiet abyss. The deep scattering layer reminds us that the ocean is not uniform. It is structured, layered, with different zones supporting different forms of life. And much of that structure is dynamic, changing hour by hour, day by day, as organisms move through the water in patterns shaped by millions of years of evolution. It also reminds us how much remains hidden. The DSL was not discovered until humans developed sonar and began systematically listening to the ocean. Before that, it existed unseen and unknown, a massive daily migration occurring beneath ships that had no idea it was there. What else might be occurring in the ocean, at depths or in locations we have not yet observed? What other patterns, other movements, other concentrations of life might exist waiting to be discovered? The image of that layer, suspended in darkness, teeming with silent life, can rest in the mind. Countless small creatures, each following ancient instincts, rising and falling with the rhythm of the sun. The water above them growing dark, the water below them growing light, and they move through that gradient, perfectly adapted to their vertical world. The breathing slows to match their slow ascent and descent. The mind drifts with them, neither rising nor falling, but suspended, weightless, in the quiet space between light and darkness. The sounds of drowning ships, final transmissions. In maritime history, there exists a category of recordings that are both fascinating and deeply unsettling: the final transmissions from ships in distress. These are the last words spoken by captains and crew members as their vessels sink, captured by radio equipment and preserved for posterity. The recordings range from calm and professional to panicked and desperate, but all share a common thread. They are voices speaking from the boundary between life and death, from the moment when a ship transitions from a vessel of hope to a tomb of water. The SS Andrea Doria, an Italian luxury liner, collided with the Swedish ship Stockholm in thick fog off the coast of Nantucket on July 25, 1956. The collision tore a massive hole in the Andrea Doria's starboard side, flooding multiple compartments. The ship began listing immediately, making it difficult to launch lifeboats. The radio operator transmitted distress signals continuously as the ship slowly capsized. The transmissions were professional, giving the ship's position and requesting immediate assistance. But as the list increased and water flooded the radio room, the transmissions became more urgent. The final message, sent just before the radio equipment was submerged, was brief. "We are abandoning ship. Require immediate assistance." 51 people died in the collision and sinking. Over 1,600 were rescued by ships that responded to the distress calls. The Andrea Doria sank 11 hours after the collision, settling on the ocean floor at a depth of approximately 70 meters. The wreck remains there, a popular but dangerous site for technical divers, slowly deteriorating in the cold Atlantic waters. The Edmund Fitzgerald, a Great Lakes freighter, sank in Lake Superior during a severe storm on November 10, 1975. The ship was carrying 26,000 tons of iron ore and had been battling heavy seas and snow for hours. Radio communication with the Fitzgerald had been intermittent throughout the day, but the crew had not indicated any serious problems. The last transmission from the Fitzgerald came at approximately 7:10 p.m. The captain of a nearby ship, the Arthur M. Anderson, asked the Fitzgerald's first mate how they were doing. The response was brief and calm. "We are holding our own." Minutes later, the Fitzgerald disappeared from radar. No further transmissions were received. No distress signal was sent. The ship, with all 29 crew members aboard, simply vanished. When wreckage was located days later, the ship had broken in two and was lying on the lake floor at a depth of 160 meters. The sinking of the Fitzgerald remains controversial. Investigations suggested that the ship had struck an underwater reef earlier in the voyage, damaging its hull, and that waves later broke through the weakened structure, flooding the cargo hold. The weight of the water combined with the weight of the ore caused the ship to sink rapidly, possibly in less than a minute. The crew would have had no time to react, no time to send a distress signal, no time even to understand what was happening. The SS Marine Electric, a coal carrier, sank off the coast of Virginia during a winter storm on February 12, 1983. The ship had been struggling against heavy seas when cracks appeared in the hull. Water began flooding the cargo holds. The captain ordered the crew to abandon ship and distress signals were transmitted. Coast Guard helicopters arrived and began rescuing crew members from the frigid water. But conditions were extreme. High winds, massive waves, temperatures near freezing. Many crew members died of hypothermia before they could be rescued. The radio transmissions from the helicopters captured the desperation of the situation, pilots and rescue swimmers working frantically to pull survivors from the water while battling the storm. 31 of the 34 crew members died. The 3 survivors were pulled from the water suffering from severe hypothermia and exposure. One survivor later described the sinking. The ship tilted sharply, throwing crew members into the sea, then rolled completely over and sank in less than a minute. Those who survived did so because they happened to be near inflatable life rafts that deployed automatically. The Marine Electric disaster led to significant reforms in ship safety regulations, including requirements for survival suits and improved inspection standards for aging vessels. But no regulations can eliminate the fundamental danger of the sea. Ships still sink, crews still die, and the ocean still claims its victims with indifference. Not all final transmissions come from sinking ships. Some come from vessels that simply disappear, their fate unknown, their final words offering only hints of what went wrong. The MV Derbyshire, a British bulk carrier, vanished in the Pacific Ocean during Typhoon Orchid in September 1980. The ship was carrying 158,000 tons of iron ore and had 44 crew members aboard. The last transmission from the Derbyshire reported that the ship was battling heavy weather, but gave no indication of serious problems. Then, silence. For years, the ship's fate was unknown. The wreck was eventually located in 1994, lying at a depth of over 4,000 metres. Investigation of the wreck revealed that the forward hatch covers had failed, allowing water to flood the cargo holds. The ship sank rapidly, possibly breaking apart as it descended. The Soviet submarine K-129 also disappeared in 1968, sinking in the Pacific Ocean with all 98 crew members. The Soviet Navy conducted extensive searches but never located the wreckage. The United States, which had been tracking K-129, did locate the wreck and, in one of the most ambitious covert operations of the Cold War, attempted to recover it using a specially built ship, the Hughes Glomar Explorer, ostensibly designed for deep-sea mining. The recovery operation, codenamed Project Azorian, managed to raise portions of the submarine from a depth of over 5,000 metres. Some of the crew remains were recovered and given burial at sea with military honours, but much of the submarine, including its nuclear warheads and code equipment, broke apart during the lift and fell back to the seafloor. The operation remained classified for decades. The French submarine Eurydice also vanished in 1968, disappearing in the Mediterranean with 57 crew members. The wreck was eventually found, crushed at depth, but the cause of the sinking remains uncertain, and the Israeli submarine Ernst Dakar disappeared in the Mediterranean in January 1968, while transiting from the United Kingdom to Israel. The wreck was not located until 1999, lying at a depth of nearly 3,000 metres. All 69 crew members died. 4 submarines, 4 different navies, all lost in the same year. The coincidence sparked speculation about a shared cause: secret weapons tests, seismic activity, interference from unidentified underwater craft. But the more prosaic explanation is that 1968 was simply a statistically unlucky year, and that submarines are inherently dangerous vessels operating in an unforgiving environment where small mistakes or equipment failures can have catastrophic consequences. Submarine disasters continue. In 2000, the Russian submarine Kursk sank in the Barents Sea after explosions in the torpedo compartment. The submarine settled on the seafloor at a depth of 108 metres, and 23 crew members survived the initial sinking, trapped in the aft compartments. They lived for several hours, possibly days, before oxygen ran out and they suffocated. All 118 crew members died. The disaster was compounded by the Russian Navy's slow response and refusal of international assistance. In 2017, the Argentine submarine ARA San Juan vanished in the South Atlantic with 44 crew members. The wreck was located a year later at a depth of 907 metres, imploded and shattered. The cause was determined to be water entering the submarine through a damaged snorkel valve, causing a short circuit, a fire, and eventually catastrophic flooding. The crew likely had only seconds of awareness before the hull collapsed under pressure. In 2021, the Indonesian submarine KRI Nanggala disappeared during a torpedo drill. It was found days later, broken into 3 sections on the seafloor at a depth of 839 metres. All 53 crew members died. The submarine had exceeded its maximum operating depth, possibly due to an internal wave or equipment malfunction, and the hull had imploded. Each of these disasters follows a similar pattern. The submarine is operating normally, then something goes wrong. Equipment fails, water enters, an explosion occurs, the hull is breached. The crew realizes they are in trouble. They attempt to surface or to repair the damage, but submarines sink quickly. Once flooding begins, the added weight makes surfacing nearly impossible. The crew has minutes, sometimes only seconds, before the situation becomes irreversible, and at depth, there is no escape. Modern submarines carry emergency escape systems, but these only work in relatively shallow water. Below a few hundred metres, the pressure is too great. Escape hatches cannot be opened. Emergency buoys cannot deploy. The crew is trapped inside a steel cylinder that is rapidly filling with water or losing air or being crushed by pressure. The psychological horror of this situation is difficult to comprehend. The crew knows they are doomed. They know rescue is impossible. They know that within hours, perhaps minutes, they will be dead. Some submarines carry enough air and emergency supplies, that the crew might survive for days, trapped in darkness, waiting for the inevitable. Other submarines flood or implode so quickly that death is instantaneous. It is unclear which is preferable. The ocean floor is littered with the wrecks of submarines. Some have been located and documented, others remain lost, their positions unknown, their crews entombed in steel coffins lying on the seabed. The wrecks are, in many cases, considered war graves, protected sites where the remains of crew members rest. They are not to be disturbed, not to be salvaged, not to be visited except under the most respectful circumstances. These lost submarines remind us that the ocean is not merely unexplored, it is dangerous. It is a place where mistakes are fatal, where equipment failure leads not to inconvenience but to death, where the margin for error of the crew survived. No distress signal was sent. The ship and everyone aboard simply vanished during the height of the typhoon. SS Waratah, a passenger liner, disappeared off the coast of South Africa in July 1909, carrying 201 passengers and crew. The ship sent no distress signal. It simply failed to arrive at its destination. Despite extensive searches, no wreckage was ever found. The disappearance sparked numerous theories. The ship encountered a rogue wave, it was struck by lightning, it suffered a catastrophic boiler explosion. But without wreckage or survivors, the truth remains unknown. The Waratah joined the ranks of ghost ships, vessels that vanish without explanation, leaving only questions. These stories, and others like them, reveal the ocean's capacity for sudden and total destruction. A ship can be sailing normally, crew members going about their duties, and minutes later the ship is gone, sunk, with everyone aboard dead or dying. The transition from routine to catastrophe can occur so quickly that there is no time to react, no time to send detailed distress messages, sometimes no time to send any message at all. The ocean does not give warnings. It does not provide time to prepare. A wave strikes, a hull ruptures, water floods in, and the ship goes down. In warm waters, survivors might last hours in the water, waiting for rescue. In cold waters, hypothermia kills in minutes. Either way, once the ship is gone, the ocean has claimed another victim. Modern technology has made maritime travel safer. Ships carry sophisticated weather prediction equipment, allowing them to avoid the worst storms. Navigation systems prevent collisions and groundings. Emergency beacons automatically transmit distress signals when a ship sinks. Survival suits protect crew members from hypothermia. Rescue coordination is faster and more effective, yet ships still sink. Every year, dozens of vessels are lost at sea worldwide. Some sink in dramatic fashion, during hurricanes or in collisions, making international news. Others disappear quietly. Small fishing boats or cargo vessels that vanish during routine voyages. Their loss noted only in maritime databases and in the hearts of families who never see their loved ones return. The ocean is patient. It has claimed countless ships over millennia of human seafaring. Wooden sailing vessels, iron steamships, steel cargo carriers, modern container ships, all types, all eras. Some wrecks lie in shallow water, accessible to divers, slowly breaking apart under the action of waves and currents. Others rest in the abyss, thousands of meters down, crushed by pressure, colonized by deep-sea organisms, slowly being buried under sediment. These wrecks are time capsules. They preserve moments. The moment when everything went wrong, when the ship began its final journey downward, when the crew realized they were not going to survive. The physical evidence remains. Dishes in the galley, tools in the engine room, personal effects in crew cabins. The ship froze in time the moment it sank, and it remains there, unchanging, a monument to loss. The final transmissions from these ships are similarly frozen. Radio recordings preserve the last words, the last requests for help, the last expressions of hope that rescue might arrive in time. Listening to these recordings is difficult. The voices are calm or panicked, professional or desperate, but always human. They are people facing death, knowing or suspecting that they will not survive, yet continuing to do their duty, transmitting information, trying to save others even as they themselves are beyond saving. The ocean cares nothing for these transmissions. It does not hear the distress signals, does not respond to the calls for help. It simply continues, waves rising and falling, currents flowing, the surface reflecting the sky above. And beneath that surface the ships rest, silent, their crews still aboard, claimed by the water and held in the deep. The image of a ship sinking, slowly tilting, water pouring through ruptured hull plates can rest in the mind without fear. The calm recognition that the ocean is powerful, that ships are fragile, that the boundary between floating and sinking is thinner than it appears. The breathing slows, the body relaxes into the stillness. The mind accepts the ocean's indifference as neither cruel nor kind, simply as what is. And in that acceptance, there is a quiet space, a place of rest. The giant pyrosomes, living tubes of light. In March 2017, divers off the coast of New Zealand encountered something extraordinary. Drifting in the open water, suspended vertically, was a translucent tube approximately 8 meters long and over 1 meter in diameter. The tube was hollow, open at one end, closed at the other, and its walls glowed with soft bioluminescence. One of the divers swam into the interior of the tube, and videos of the encounter quickly went viral. The creature was a pyrosome, a colonial organism composed of thousands of individual zooids, each a tiny filter-feeding animal, all connected and working together as a single entity. The name pyrosome comes from the Greek words for fire body, referring to the bioluminescent glow these organisms produce when disturbed. Pyrosomes have been known to science for centuries, but they are rarely encountered by humans because they typically live in the open ocean, far from shore, drifting with currents in waters too deep for casual observation. They are most common in tropical and subtropical waters, though they occasionally appear in temperate regions during warm water intrusions. The individual zooids that make up a pyrosome are small, typically just a few millimeters in length. Each zooid is a tunicate, a simple organism with a sac-like body, an inlet siphon that draws water in, and an outlet siphon that expels water. The zooid filters plankton and organic particles from the water, extracting nutrients. The outlet siphons of all the zooids face outward, so water is drawn into the interior of the tube and expelled through the walls, creating a gentle current that propels the entire colony slowly through the water. A single pyrosome colony can contain tens of thousands or even millions of zooids, all genetically identical, all clones of the original founding zooid. The colony grows by budding. Each zooid produces new zooids, which remain attached, gradually expanding the size of the tube. In favourable conditions, pyrosomes can grow rapidly, adding meters to their length in just weeks. Most pyrosomes are small, less than a meter in length, but under certain conditions they can grow to enormous sizes. The specimen encountered off New Zealand in 2017 was 8 meters long, but there are reports of pyrosomes exceeding 10 meters, and possibly even longer. These giant pyrosomes are rare, and their biology is poorly understood because opportunities to study them are infrequent. The bioluminescence of pyrosomes is one of their most striking features. When disturbed by a diver's hand, by the wake of a boat, or even by movement in the surrounding water, the zooids emit light. The light is blue-green, produced by a chemical reaction involving luciferin and luciferase, the same basic mechanism used by fireflies and many marine organisms. The glow spreads across the colony in waves, creating patterns of light that shimmer and pulse. The function of this bioluminescence is not entirely clear. It may serve as a defense mechanism, startling predators or making the colony more visible to other predators who might attack the initial predator. Or it may be a form of communication, coordinating the behavior of the individual zooids. Or it may simply be an accidental byproduct of the zooid's metabolic processes with no particular adaptive function. Pyrosomes are fragile, their gelatinous bodies are easily damaged, and colonies often break apart when handled or when washed ashore. Dead or dying pyrosomes sometimes wash up on beaches, where they appear as translucent gelatinous lumps, often mistaken for jellyfish. In some regions, mass strandings of pyrosomes have occurred, with thousands of individuals washing ashore over the course of days or weeks. These strandings are poorly understood. They may be related to changes in ocean currents that push pyrosome populations towards shore. Or they may result from population blooms, rapid increases in pyrosome numbers, that exhaust local food supplies, causing the organisms to weaken and die. Some researchers have suggested that climate change may be increasing the frequency of pyrosome blooms by altering ocean temperatures and nutrient distributions. Pyrosomes play an ecological role that is only beginning to be understood. As filter feeders, They consume plankton and organic particles, converting that biomass into their own tissues. When pyrosomes die, they sink, carrying that biomass into the deep ocean, where it becomes food for deep-sea organisms. This vertical transport of carbon is part of the biological pump that helps regulate atmospheric carbon dioxide levels. But pyrosomes may also affect marine ecosystems in less beneficial ways. During blooms, they can consume enormous quantities of plankton, potentially competing with other filter feeders like fish larvae and small crustaceans. Some fish species feed on pyrosomes, but most predators avoid them. The gelatinous tissue has low nutritional value, and the bioluminescence may make them unappealing or difficult to capture in the dark. Encounters with giant pyrosomes are memorable for divers who experience them. The organisms drift slowly, seemingly aimless, glowing faintly in the surrounding water. Swimming inside the hollow tube, a diver is surrounded by translucent walls that pulse with light at the slightest touch. The water inside the tube is clear, filtered by the thousands of zooids, and the experience is described as otherworldly, like being inside a living lantern. But these encounters are rare. Giant pyrosomes are unpredictable in their appearance. They may be absent from a region for years, then suddenly appear in large numbers during a single season before vanishing again. Scientists studying pyrosomes often rely on opportunistic sightings by divers or fishermen, as systematic surveys of open ocean waters rarely capture them. The life cycle of pyrosomes is complex. They reproduce both sexually and asexually. Sexual reproduction involves the release of eggs and sperm into the water, where fertilization occurs. The fertilized eggs develop into larvae that eventually settle and form new colonies. Asexual reproduction, through budding, allows existing colonies to grow and expand. The balance between these two reproductive strategies and how they are influenced by environmental conditions remains incompletely understood. There is also the question of lifespan. Individual zooids live for only a short time, perhaps weeks or months, but the colony as a whole can persist much longer, continuously producing new zooids to replace those that die. How long a pyrosome colony can survive, and what factors determine when it dies and breaks apart, are questions with few answers. Pyrosomes exist in that strange category of marine life that is both well documented and deeply mysterious. We know what they are, how they feed, how they reproduce. But we do not know why they bloom when they do, why some colonies grow to giant sizes while most remain small, or what role they play in the broader ocean ecosystem. They drift through the open ocean, glowing softly in the darkness, largely unnoticed except by the occasional diver or research vessel. The ocean holds countless such organisms, known but not understood, documented but not explained. They live out their lives in the vastness of the water, following patterns shaped by evolution and environment, and we catch only glimpses of them, brief moments of encounter that leave more questions than answers. The image of that glowing tube, drifting in deep blue water, can rest in the mind. Translucent walls pulsing with soft light, the gentle current of water flowing through the hollow interior, the thousands of tiny organisms working in silent coordination, each one insignificant, but together forming something remarkable. The breathing slows to match that gentle rhythm. The mind drifts with the current, and in that drifting there is peace. The sound of the earth opening, mid-ocean ridges. The longest mountain range on Earth is not the Himalayas, the Andes, or the Rockies. It is the mid-ocean ridge system, a continuous chain of underwater mountains that extends for over 65,000 kilometers, winding through every major ocean basin. This range is taller than any terrestrial mountain range, with peaks rising 3 to 4 kilometers above the surrounding seafloor. And unlike terrestrial mountains, which are formed by the collision of tectonic plates, the mid-ocean ridges are formed by plates pulling apart. At the ridges, the Earth's crust is being created. Magma from the mantle rises through cracks in the seafloor, cools, and solidifies, forming new oceanic crust. This process, called seafloor spreading, occurs continuously along the entire length of the ridge system. The rate is slow, typically a few centimeters per year, but over geological time, it has profound effects. The Atlantic Ocean, for instance, is widening by about 2.5 centimeters per year as new crust forms at the mid-Atlantic ridge. Over millions of years, this slow spreading has opened an entire ocean basin. The ridges are not smooth. They are fractured and broken, cut by transform faults where sections of crust slide past each other, creating earthquakes. The ridge crest itself is often marked by a rift valley, a deep crack running along the spine of the mountain range where the newest crust is forming. This rift is a place of intense geological activity, volcanic eruptions, hydrothermal vents, earthquakes, and chemical reactions that alter the composition of seawater. Hydrothermal vents are among the most remarkable features of the mid-ocean ridges. These vents occur where seawater seeps into cracks in the seafloor, is heated by magma below, and then erupts back into the ocean as superheated water loaded with dissolved minerals. The water can reach temperatures exceeding 400 degrees Celsius, hot enough to melt lead, yet it remains liquid because of the immense pressure at depth. When this superheated water meets the cold ocean water, the dissolved minerals precipitate out, forming clouds of particles that look like black or white smoke. These are called black smokers and white smokers, depending on the mineral composition. The minerals accumulate around the vent openings, building chimney-like structures that can grow several meters tall. Around these vents, entire ecosystems have evolved. Ecosystems that do not rely on sunlight. At the base of these food webs are bacteria that metabolize the chemicals in the vent water, hydrogen sulfide, methane, and other compounds, through a process called chemosynthesis. These bacteria form the foundation for a community of organisms unlike any found elsewhere on Earth. Tube worms, some over 2 meters long, cluster around the vents. They have no mouth, no stomach, no digestive system. Instead, they have a specialized organ called a trophosome, packed with symbiotic bacteria that convert vent chemicals into nutrients. The worm absorbs these nutrients directly from the bacteria. It is a partnership millions of years old, so complete that neither organism can survive without the other. There are also yeti crabs covered in hair-like setae that harbour bacteria. The crabs wave their claws in the vent water, farming the bacteria, and then scrape them off and eat them. There are snails with iron-infused shells, shrimp with heat-sensing organs on their backs, and fish that have adapted to temperatures that would cook most marine life. These vent ecosystems were discovered only in 1977, during a deep-sea expedition to the Galapagos Rift. Before that discovery, scientists believed that all life on Earth ultimately depended on photosynthesis. The existence of chemosynthetic ecosystems fundamentally changed our understanding of life's possibilities. If life can thrive in the complete absence of sunlight, deriving energy from chemical reactions alone, then life might be possible in environments previously thought sterile, beneath the ice of Europa, in the subsurface of Mars, in the interiors of comets. The discovery also raised questions about the origin of life on Earth. Many scientists now believe that life may have begun at hydrothermal vents, where the chemical energy and mineral-rich environment provided ideal conditions for the first self-replicating molecules to form. The earliest life may have been chemosynthetic bacteria, living in the darkness of the seafloor, long before photosynthesis evolved and life colonized the sunlit surface. The mid-ocean ridges are also places of sound. The geological activity creates acoustic phenomena that propagate through the water for hundreds or thousands of kilometers. Earthquakes along the ridge system produce low-frequency rumbles that can be detected by hydrophones on the other side of an ocean basin. Volcanic eruptions create loud, sustained roars as magma erupts and cools rapidly in contact with seawater. The formation and collapse of vent chimneys produces crackling and popping sounds. Some of these sounds are beyond human hearing, too low in frequency to be perceived, but they carry through the ocean with remarkable efficiency. Low-frequency sounds suffer less attenuation in water, allowing them to travel vast distances. A powerful earthquake at one end of a ridge system might be heard by sensitive instruments at the other end, thousands of kilometers away. There are also sounds we do not yet understand. In recordings from hydrophones placed near ridge systems, researchers have detected acoustic signals that do not match known geological or biological sources. Some are brief pulses, others sustained tones. Some occur regularly, others sporadically. The origin of these sounds remains unclear, but they suggest that the ridge environment is acoustically complex, with processes we have not yet identified. The mid-ocean ridges are largely unexplored. The ridge system is vast and only small sections have been visited by submersibles or mapped in detail. New vent sites are discovered regularly, each with its own community of organisms, some of which are new to science. The ridges extend into polar regions, into the deepest parts of the ocean, into areas so remote that no human has ever been nearby. And the ridges are changing. Volcanic activity is not constant. Some sections of the ridge system are highly active, with frequent eruptions and abundant hydrothermal vents. Other sections are dormant, the crust having cooled and solidified, the vents long extinct. The distribution of activity shifts over time as magma chambers beneath the ridge wax and wane, as tectonic stresses change, as the Earth's internal heat flow varies. There may be ridge sections that are temporarily inactive but will reawaken in the future. There may be newly active sections that have not yet been discovered, and there may be ridge features, vents, volcanic peaks, geological formations that exist only briefly before being destroyed by subsequent activity. The image of the ridge, a crack in the Earth's crust thousands of kilometers long, can form in the mind. Magma glowing red in the darkness, meeting cold seawater and solidifying into black rock. Hydrothermal vents belching superheated water and minerals, building chimneys that reach upward toward the distant surface. Life clustering around these vents, thriving in conditions that would kill most organisms, testament to evolution's creativity and persistence. And above it all, the weight of the ocean, kilometers of water pressing down, cold and dark, isolating the ridge from the surface world. The ridge exists in darkness, known only through instruments and the occasional visit by submersibles. It creates the seafloor, shapes the ocean basins, drives plate tectonics, and yet it remains largely hidden, a fundamental feature of our planet that most people will never see. The breathing slows, the mind descends toward that darkness, that place where the Earth opens and reveals its molten interior, where water and rock meet at impossible temperatures, where life finds a way even in the most extreme conditions. And in that darkness, in that deep place, there is a kind of stillness, a recognition that the Earth is constantly creating itself, building new crust, opening new spaces, and that this process has been happening for billions of years and will continue long after humanity is gone. The disappeared submarines, vessels lost in silence. Submarines are designed to disappear. They submerge beneath the waves, becoming invisible to surface observation, relying on stealth to accomplish their missions. But sometimes, submarines disappear in a different way, not as part of their mission, but permanently, lost in the depths with all hands aboard, their fate unknown or only partly understood. The history of submarine warfare is also a history of submarine disasters. Since the first military submarines entered service in the early 20th century, dozens have been lost at sea. Some sank in combat, struck by depth charges or torpedoes. Others were lost in accidents, collisions, fires, equipment failures, or simply diving to depths beyond their hull's capacity and being crushed by pressure. One of the most mysterious submarine disappearances occurred in 1968, a year that would see 4 submarines from different nations lost in separate incidents. The USS Scorpion, a nuclear-powered attack submarine of the United States Navy, was returning from deployment in the Mediterranean when it vanished in the Atlantic Ocean. The Scorpion's last confirmed position was approximately 400 miles southwest of the Azores. Radio contact was routine. The submarine was expected to arrive at its home port in Norfolk, Virginia, on May 27, 1968. It never arrived. When the submarine failed to make scheduled communications, a search was initiated. Weeks later, the wreckage was located on the seafloor at a depth of over 3,000 meters. The submarine had imploded. The hull was crushed, broken into sections, scattered across the seafloor. All 99 crew members were killed. The cause of the sinking has never been definitively determined. Official investigation suggested several possibilities. A malfunctioning torpedo that exploded while still in its tube, flooding that exceeded the submarine's ability to surface, or catastrophic equipment failure. But no definitive evidence supports any single theory. Conspiracy theories have flourished in the absence of certainty. Some suggest the Scorpion was sunk by a Soviet submarine in retaliation for an earlier incident. Others propose that the submarine's nuclear reactor experienced a catastrophic failure. Still others point to potential sabotage or design flaws that the Navy has never publicly acknowledged. The truth, if it exists in any recoverable form, lies in the wreckage on the seafloor, and the Navy has never authorized a full forensic examination of the site. The Soviet submarine K-129 also disappeared in 1968, sinking in the Pacific Ocean with all 98 crew members. The Soviet Navy conducted extensive searches but never located the wreckage. The United States, which had been tracking K-129, did locate the wreck and, in one of the most ambitious covert operations of the Cold War, attempted to recover it using a specially built ship, the Hughes Glomar Explorer, ostensibly designed for deep-sea mining. The recovery operation, codenamed Project Azorian, managed to raise portions of the submarine from a depth of over 5,000 meters. Some of the crew remains were recovered and given burial at sea with military honors. But much of the submarine, including its nuclear warheads and code equipment, broke apart during the lift and fell back to the seafloor. The operation remained classified for decades. The French submarine Eurydice also vanished in 1968, disappearing in the Mediterranean with 57 crew members. The wreck was eventually found, crushed at depth, but the cause of the sinking remains uncertain. And the Israeli submarine INS Dakar disappeared in the Mediterranean in January 1968 while transiting from the United Kingdom to Israel. The wreck was not located until 1999, lying at a depth of nearly 3,000 meters. All 69 crew members died. 4 submarines, 4 different navies, all lost in the same year. The coincidence sparked speculation about a shared cause, secret weapons tests, seismic activity, interference from unidentified underwater craft. But the more prosaic explanation is that 1968 was simply a statistically unlucky year, and that submarines are inherently dangerous vessels operating in an unforgiving environment where small mistakes or equipment failures can have catastrophic consequences. Submarine disasters continue. In 2000, the Russian submarine Kursk sank in the Barents Sea after explosions in the torpedo compartment. The submarine settled on the seafloor at a depth of 108 meters, and 23 crew members survived the initial sinking, trapped in the aft compartments. They lived for several hours, possibly days, before oxygen ran out and they suffocated. All 118 crew members died. The disaster was compounded by the Russian Navy's slow response and refusal of international assistance. In 2017, the Argentine submarine ARA San Juan vanished in the South Atlantic with 44 crew members. The wreck was located a year later at a depth of 907 meters, imploded and shattered. The cause was determined to be water entering the submarine through a damaged snorkel valve, causing a short circuit, a fire, and eventually catastrophic flooding. The crew likely had only seconds of awareness before the hull collapsed under pressure. In 2021, the Indonesian submarine KRI Nanggala disappeared during a torpedo drill. It was found days later, broken into 3 sections on the seafloor at a depth of 839 meters. All 53 crew members died. The submarine had exceeded its maximum operating depth, possibly due to an internal wave or equipment malfunction, and the hull had imploded. Each of these disasters follows a similar pattern. The submarine is operating normally, then something goes wrong. Equipment fails, water enters, an explosion occurs, the hull is breached. The crew realizes they are in trouble. They attempt to surface or to repair the damage. But submarines sink quickly. Once flooding begins, the added weight makes surfacing nearly impossible. The crew has minutes, sometimes only seconds, before the situation becomes irreversible, and at depth, there is no escape. Modern submarines carry emergency escape systems, but these only work in relatively shallow water. Below a few hundred meters, the pressure is too great. Escape hatches cannot be opened. Emergency buoys cannot deploy. The crew is trapped inside a steel cylinder that is rapidly filling with water, or losing air or being crushed by pressure. The psychological horror of this situation is difficult to comprehend. The crew knows they are doomed. They know rescue is impossible. They know that within hours, perhaps minutes, they will be dead. Some submarines carry enough air and emergency supplies that the crew might survive for days, trapped in darkness, waiting for the inevitable. Other submarines flood or implode so quickly that death is instantaneous. It is unclear which is preferable. The ocean floor is littered with the wrecks of submarines. Some have been located and documented. Others remain lost, their positions unknown, their crews entombed in steel coffins lying on the seabed. The wrecks are, in many cases, considered war graves, protected sites where the remains of crew members rest. They are not to be disturbed, not to be salvaged, not to be visited except under the most respectful circumstances. These lost submarines remind us that the ocean is not merely unexplored, It is dangerous. It is a place where mistakes are fatal, where equipment failure leads not to inconvenience but to death, where the margin for error is measured in seconds. The crews who serve on submarines accept these risks, understanding that their chosen profession places them in one of the most hazardous environments humans regularly occupy. The ocean claims these vessels and holds them. The cold, dark water preserves the wrecks remarkably well. Unlike wrecks in shallow water, which corrode quickly and are colonized by organisms that accelerate deterioration, deep water wrecks remain largely unchanged for decades. The pressure, the cold, and the lack of oxygen slow all processes. The submarines rest on the seafloor, silent monuments to those who died within them, and they are not alone. The seafloor holds hundreds of wrecks, not just submarines, but all manner of vessels lost over centuries of maritime history. Each wreck tells a story of disaster, of lives lost, of the ocean's power to claim what ventures upon it. The deep sea is a graveyard, vast and quiet, where the drowned rest in darkness. The image of a submarine, intact or broken, resting on the ocean floor can form without horror. The cold metal hull, the sediment slowly accumulating on its surfaces, the deep-sea organisms making their homes in and around it. The crew, if any remains exist, resting where they fell, claimed by the water and held in eternal stillness. The mind accepts this without fear, recognizing it as part of the ocean's nature. The breathing slows, the body relaxes, and in that relaxation there is acknowledgement that the ocean is both beautiful and deadly, both wondrous and terrible, and that these qualities coexist without contradiction. The Phantom Islands, lands that never were. For centuries, maritime charts showed islands in the middle of oceans, islands that sailors reported seeing, islands that captains marked on their logs, islands that appeared on map after map, copied from earlier sources and assumed to be real. But when modern survey ships and aircraft searched for these islands, they found nothing. Empty ocean. The islands had never existed. These phantom islands are cartographic ghosts, artifacts of misidentification, wishful thinking, and the limitations of early navigation. Some originated from genuine errors, sailors mistaking clouds, fog banks, or distant icebergs for land. Others were deliberate fabrications placed on maps to confuse rivals or to claim territorial rights over empty ocean. Still others emerged from mythological traditions and were incorporated into maps because the boundary between legend and geography was not clearly defined. One of the most famous phantom islands is High Brazil, which appeared on maps of the North Atlantic for centuries. Located west of Ireland, the island was described as circular, divided by a river and shrouded in mist. Irish legend spoke of it as an enchanted island, visible only once every 7 years, a paradise where an advanced civilization dwelled. Sailors occasionally reported sighting it, and expeditions were mounted to find it, but no physical island was ever discovered. High Brazil was eventually removed from official charts in the 19th century, acknowledged as myth. The island of California is another notable example. Early Spanish explorers, misunderstanding the geography of the region, depicted California as an island separated from the North American mainland by a narrow strait. This error persisted on maps for over a century, even after land expeditions proved California was a peninsula. The Phantom Island appeared because mapmakers copied from earlier sources without verification, and because correcting an established geographical feature was considered more controversial than perpetuating an error. Freeland was a phantom island supposedly located south of Iceland. It appeared on maps from the 16th century onward, sometimes depicted as a large island, other times as an archipelago. The island was supposedly discovered by Venetian explorers in the 14th century, but modern analysis suggests the entire account was fabricated. Freeland may have originated from a misidentified sighting of existing islands, or it may have been entirely fictional. It was removed from maps in the 18th century. The most scientifically investigated phantom island is Sandy Island, which appeared on maps of the Coral Sea northeast of Australia. The island appeared on charts as recently as 2012, despite the fact that no one had ever confirmed its existence. When an Australian research vessel sailed to the charted location in 2012, they found water over 400 metres deep. No island, no reef, no shallow water. Sandy Island was officially removed from maps, and the reason for its inclusion remains unclear. It may have originated from a sighting of a pumice raft, floating volcanic debris that can resemble land from a distance, or it may have been a charting error that was never corrected. Phantom islands are not merely historical curiosities, they reflect the difficulty of navigation and surveying in the age before GPS and satellite imagery. The ocean is vast, visibility is often poor, and distinguishing between clouds, fog, icebergs, and actual land is not always straightforward, especially for sailors who have been at sea for weeks and are eager to make landfall. Optical illusions, such as Fata Morgana mirages, can create the appearance of distant land where none exists. And in the absence of reliable longitude measurement, positioning islands accurately was nearly impossible. But some phantom islands may have had actual, temporary physical origins. Volcanic islands occasionally emerge from the sea, exist for a few years or decades, and then erode away or sink back beneath the waves. If a sailor encountered such an island, charted its position, and returned years later to find it gone, the island would become phantom, reported but unverifiable. This phenomenon still occurs. In 2015, the submarine volcano Hunga Tonga erupted, creating a new island in the South Pacific. The island persisted for several years before eroding away. If this had occurred in the age of sail, the island might have been charted, named, and then later deemed phantom when subsequent expeditions found only open water. There are also submerged reefs and seamounts that come close to the surface but do not breach it. These can create dangerous shoals, areas of shallow water where waves break and ships can run aground. If a sailor encountered such a feature, they might report an island or describe it as a barely submerged rock. Later ships, passing nearby at high tide or in calm conditions, might find deep water and conclude the island did not exist. The ocean floor is not static. Tectonic activity, volcanic eruptions, and sediment deposition constantly reshape the seafloor. It is possible, though rare, for features that were once above water to sink or for submerged features to rise. A reported island that disappears might not be entirely phantom. It might simply have moved below the waterline. Phantom islands also appear in polar regions where ice can be mistaken for land. Icebergs, ice shelves, and pack ice can create the appearance of solid ground, especially in poor visibility or when viewed from a distance. Early Arctic and Antarctic explorers charted numerous islands that were later determined to be ice features, not land. These islands moved with currents, melted in warmer seasons, and eventually disappeared, leaving only their names on outdated maps. The removal of phantom islands from official charts has been a gradual process, spanning centuries. As surveying technology improved, first with accurate chronometers allowing precise longitude measurement, then with aerial photography, and finally with satellite imagery, the oceans could be mapped with unprecedented accuracy. Features could be confirmed or disproven definitively. The phantom islands, one by one, were eliminated, but they retain a certain romantic appeal. They represent the ocean as a place of mystery, where the boundary between reality and imagination was permeable, where sailors ventured into the unknown and sometimes saw things that may or may not have been there. They remind us that maps are not neutral documents but interpretations, shaped by the information available, the biases of the cartographer, and the demands of the cultures that produced them. And perhaps, in some small way, they remind us that the ocean still holds secrets. Modern surveys have mapped the ocean floor with remarkable precision, but the resolution is not perfect. Small islands, rocky outcrops, or temporary volcanic features might exist in remote regions without being detected. The probability is low, but not zero. The ocean is vast, and while satellite imagery has eliminated the possibility of undiscovered large islands, it has not eliminated all possibility of surprises. The image of an island that does not exist, that appears on maps but not in reality, can rest in the mind. A place that sailors searched for, that captains claimed to have seen, that appeared and then vanished like a dream. The ocean preserving the possibility, the uncertainty, the sense that seeing is not always the same as finding. The breathing slows. The mind drifts toward that uncertain place, that space between what is and what is imagined. And in that drift, in that gentle letting go of certainty, there is rest. The living fossils, creatures out of time. In 1938, a fishing trawler operating off the coast of South Africa hauled up a bizarre fish in its nets. The fish was large, about 1.5 meters long, with thick scales, fleshy lobed fins, and a strange tail structure unlike any fish the crew had seen. They delivered it to Marjorie Courtenay Latimer, curator of the local museum, who recognised that it was something extraordinary. She contacted J.L.B. Smith, an ichthyologist, and sent him sketches of the fish. Smith's response was immediate and dramatic. The fish was a coelacanth, a member of an ancient group of fish thought to have gone extinct 65 million years ago, at the same time as the dinosaurs. Finding a living coelacanth was equivalent to finding a living dinosaur. It was, in Smith's words, the most important natural history discovery of the century. The discovery revolutionized understanding of evolutionary history. Coelacanths belonged to a group of lobe-finned fish that were thought to represent an important stage in the evolution of land vertebrates. The fleshy fins of coelacanths were considered precursors to the limbs of tetrapods, the first animals to walk on land. But all known coelacanths existed only as fossils, preserved in rocks tens or hundreds of millions of years old. The group was believed extinct, evolutionary dead ends that left no living descendants. The discovery of a living coelacanth proved this wrong. The species had not gone extinct. It had simply moved into deep water, away from coastal regions where fossilization is most likely to occur, and had persisted unchanged for millions of years. It was a living fossil, a species that had survived multiple mass extinction events, continental drift, climate changes, and the rise and fall of countless other species. A second population of coelacanths was discovered in 1998, off the coast of Indonesia, thousands of kilometers from the South African population. Genetic analysis showed the two populations were distinct species, separated for millions of years. This suggested that coelacanths were more widespread than initially believed, inhabiting deep water environments in multiple ocean basins. Coelacanths live at depths of 100 to 700 meters, in caves and overhangs along steep underwater slopes. They are slow-moving, buoyancy-assisted predators that drift in the current, using minimal energy. They hunt small fish and squid, relying on ambush rather than pursuit. Their lobed fins, which evolutionary biologists once thought were protolimbs, are actually highly specialized for maneuvering in complex three-dimensional environments, allowing the fish to move with remarkable precision in caves and rocky terrain. The coelacanth is not unique. The deep ocean has revealed numerous living fossils, species that persist unchanged while the world around them transforms. These species occupy stable environments where evolutionary pressures are minimal. They have found ecological niches where their ancient adaptations remain effective, and they have stayed there, generation after generation, for millions of years. The goblin shark, with its elongated snout and protrusible jaws, is another example. Fossil relatives of the goblin shark date back 125 million years. The modern species is nearly identical to its ancient ancestors, suggesting minimal evolutionary change over that span. Goblin sharks live in deep water, hunting in darkness, and their bizarre appearance reflects adaptations to that environment that have proven so successful they required no modification. The frilled shark, with 6 pairs of gills and an eel-like body, has changed little in 80 million years. It hunts in deep water, feeding on squid and fish, using the same hunting techniques its ancestors used when dinosaurs still walked the earth. The species is rare and elusive, encountered only occasionally by deep-sea trawlers or research submarines. Horseshoe crabs are marine arthropods that have existed for over 400 million years, predating dinosaurs by more than 200 million years. Their body plan has remained essentially unchanged, a design so effective that evolution has found no need to modify it. Horseshoe crabs are not crabs at all, but are more closely related to spiders and scorpions. They represent an ancient lineage that has survived 5 mass extinction events. The nautilus, a cephalopod with a spiral shell, is another living fossil. Nautiloids were abundant in ancient seas, with thousands of species filling ecological niches now occupied by fish and squid. Most went extinct during the mass extinction at the end of the Cretaceous, but a few species of nautilus survived, and they persist today, largely unchanged, living in deep water in the Pacific and Indian Oceans. These living fossils raise questions about evolution and extinction. Why do some species change rapidly, adapting to new environments and evolving into diverse forms, while others remain unchanged for millions of years? Why do some lineages go extinct entirely while others persist? The answer seems to involve a combination of factors. Species that live in stable environments, particularly deep water environments, experience less selective pressure to change. The deep ocean is cold, dark, and relatively unchanging. The challenges organisms face there have remained constant for millions of years. Adaptations that work in that environment continue to work, and there is no advantage to changing. Species with generalized diets and behaviors are also more likely to persist. Specialists which depend on specific food sources or habitats are vulnerable when conditions change. Generalists can adapt to shifts in their environment by switching to different foods or moving to different areas. Many living fossils are generalists, capable of surviving in varied conditions. There is also the role of geographic isolation. Deep-sea environments are often isolated from each other by shallower water or by great distances. Populations in these isolated environments do not exchange genes with populations elsewhere, allowing unique adaptations to develop and persist. If the environment remains stable, these populations can continue unchanged for millions of years. But living fossils also remind us how much we do not know about the deep ocean. The coelacanth remained unknown to science until 1938, despite being a large, distinctive fish living in relatively accessible waters. How many other species might exist, undetected, in deeper or more remote regions? The ocean floor covers more than 360 million square kilometers. Most of it has never been directly observed by humans. Sampling is sparse, limited to areas near research stations or along shipping routes. Vast regions of the deep sea have never been surveyed. New species are discovered regularly, and occasionally those species turn out to be living fossils, lineages thought extinct but actually persisting in the deep. In 2005, a research expedition to the South Pacific discovered a new species of squat lobster living near hydrothermal vents. The species was covered in hair-like setae and was so distinctive it required the creation of a new family. The discovery demonstrated that even major groups of organisms can remain unknown until someone happens to visit the right place at the right time. There may be other coelacanths waiting to be discovered, other ancient lineages that survived extinction events and persist in deep water. The probability of finding a living dinosaur is zero. Terrestrial ecosystems have been too thoroughly explored, but the probability of finding another ancient marine lineage, thought extinct but actually surviving in the deep, is not zero. It is small, but it is real. The deep ocean is a refuge for the ancient, a place where time moves slowly and change is minimal. It preserves species, preserves ecosystems, preserves ways of life that have vanished from the rest of the planet. And it holds them in silence, in darkness, in cold water that insulates them from the rapid changes occurring above. The image of the coelacanth, drifting in a dark underwater cave, fins moving slowly, can rest in the mind. An animal unchanged for millions of years, a survivor, a remnant of ancient seas now confined to the deep. The realization that such creatures exist, that the past is not entirely gone, that evolution is not only about change but also about persistence. The breathing slows, the mind accepts the vastness of time, the patience of the ocean, the possibility that what was lost is sometimes only hidden. And in that acceptance, there is a deep calm, a quietness that echoes the stillness of the abyss. The underwater caves, labyrinths beneath the waves. Caves exist beneath the ocean, vast networks of passages, chambers and tunnels carved into rock by water over millions of years. Some of these caves are accessible from land, flooded passages that extend beneath coastal cliffs and islands. Others exist entirely underwater, entrances opening directly onto the seafloor, leading into darkness where no light has ever penetrated. These underwater caves are among the most dangerous and least explored environments on Earth. Cave diving requires specialized training, equipment, and planning. The hazards are numerous: limited visibility, narrow passages that can trap divers, silt that can be stirred up and reduce visibility to zero, complex navigation that makes getting lost easy, and the ever-present threat of running out of air far from the surface. Despite these dangers, cave divers continue to explore. They map passages, document geological features, and occasionally discover things that challenge our understanding of geology, biology, and history. One of the most famous underwater cave systems is the cenotes of Mexico's Yucatan Peninsula. Cenotes are sinkholes that form when limestone bedrock collapses, exposing groundwater below. The Maya considered cenotes sacred, using them for ceremonies and occasionally for human sacrifice. Modern divers have discovered that many cenotes connect to extensive underground river systems, some extending for hundreds of kilometers beneath the jungle. These underwater caves contain archaeological treasures, pottery, bones, and other artifacts have been found deep within the passages left by ancient peoples who explored the caves with only torches for light. Human remains have been discovered in some cenotes, individuals who either fell in accidentally or were placed there deliberately. One skeleton, dated to over 13,000 years old, is among the oldest human remains found in the Americas. The caves also contain geological formations of extraordinary beauty. Stalactites and stalagmites, formed when the caves were above water during lower sea levels, now hang submerged, coated in algae and inhabited by cave-adapted organisms. Crystal clear water allows visibility of over 100 meters in some passages, creating the illusion of flying through an alien landscape. But the Yucatan caves are relatively accessible and well explored compared to many underwater cave systems. Around the world, submerged caves remain unknown, their entrances hidden or their passages too dangerous to penetrate. In the Bahamas, blue holes, circular underwater sinkholes similar to cenotes, conceal extensive cave networks. Some passages extend hundreds of meters beneath the seafloor, branching into complex mazes. Exploration of these caves has revealed fossil remains of animals that lived when the caves were above water, including extinct species of tortoises, crocodiles, and birds. The caves preserve a record of climate change and sea level rise, with layers of sediment marking different periods. In the Mediterranean, underwater caves along the coasts of Greece, Italy, and Spain have been explored by archaeologists and cave divers. Some contain ancient artifacts, including pottery and anchors from shipwrecks. Others contain fossils of terrestrial animals that entered the caves when they were dry. And a few contain evidence of early human habitation, fire pits, tools, and bones, indicating that humans used these caves as shelter thousands of years ago. But underwater caves are not just historical or geological curiosities, they are also biological refuges. Cave-adapted species, sometimes called troglobites, have evolved to live in the unique conditions of underwater caves. These species are often blind, lacking eyes entirely or possessing only vestigial remnants. They lack pigmentation, their bodies pale or translucent, and they have highly sensitive tactile and chemical senses, allowing them to navigate and find food in complete darkness. Cave fish, cave shrimp, cave isopods, dozens of species have been discovered living in underwater caves, many of them found nowhere else. These species evolved from surface-dwelling ancestors that entered the caves and became isolated. Over millions of years, they adapted to the cave environment, losing traits that were no longer useful and developing new traits that enhanced survival in darkness. The discovery of these species raises questions about biodiversity and evolution. How many other species might exist in unexplored caves? How isolated are these cave populations? And how long have they been separated from surface populations? What do these species tell us about the processes of evolution and adaptation? Underwater caves also contain unique ecosystems driven by chemosynthesis rather than photosynthesis. In some caves, bacteria metabolize sulfur compounds or other chemicals dissolved in the water, forming the base of a food web that includes specialized invertebrates and fish. These ecosystems are fragile and extremely vulnerable to disturbance. Changes in water chemistry, pollution, or physical disturbance can collapse the entire system. The exploration of underwater caves is also driven by the search for new cave systems and the goal of connecting known passages into larger mapped networks. Cave divers push into unexplored passages, laying guidelines as they go, mapping distances and depths, documenting features. The work is slow, dangerous, and requires immense skill. A single dive might penetrate only a few dozen meters into virgin passage, and it may take years or decades to fully map a complex system, and sometimes divers find things they do not expect. In 2018, divers exploring a flooded cave system in the Yucatan discovered what appeared to be a carved stone structure deep within a passage, far beyond where natural light penetrates. The structure was clearly artificial, but its purpose and origin were unclear. How did it get there? Who built it? And why? The discovery sparked speculation about ancient Maya activities in the caves, but definitive answers remain elusive. There are also reports, difficult to verify, of divers encountering unusual features in underwater caves, passages that seem to have been carved or modified, chambers with unnaturally smooth walls, formations that resemble architecture. Most of these reports can be explained by natural geological processes or by pareidolia, the tendency to see patterns in random features. But occasionally a discovery is made that resists easy explanation. The ocean's caves extend into the unknown. Many caves are too deep for conventional scuba diving, requiring closed-circuit rebreathers or other advanced life support systems. Some passages are too narrow for divers to enter safely, others are blocked by silt or debris, and in some caves, currents or other hazards make exploration impossible with current technology. These unexplored passages may contain fossils, artifacts, or unique species waiting to be discovered. They may connect to other cave systems, forming networks that extend beneath entire regions, or they may lead nowhere. Dead-end passages that have been isolated for millions of years, containing ecosystems that evolved in complete isolation from the rest of the planet. The image of an underwater cave, dark and silent, water perfectly still, can form in the mind. The narrow beam of a dive light illuminating limestone walls, formations sculpted by water over eons, the guideline stretching back toward the entrance, the only route to safety. The profound silence, broken only by the sound of the diver's breathing and the occasional gurgle of exhaust bubbles. The sense of being in a place where few have ever been, where the rock holds secrets of deep time. The breathing slows to match the rhythm of the cave, the slow patience of stone and water. The mind descends into that darkness, into that stillness, into the labyrinth beneath the waves. And in that descent, there is no fear, only the recognition that the earth contains places beyond human reach, and that those places will keep their mysteries regardless of our curiosity. And in that recognition, there is peace. The deep ocean dead zones, waters without oxygen. Oxygen is essential for most life on Earth. Animals, plants, fungi, and many bacteria require oxygen to metabolize food and generate energy. Remove the oxygen, and most organisms die within minutes. Yet in the ocean, there are regions where oxygen is nearly or entirely absent. Dead zones where the water cannot support most forms of life. These hypoxic and anoxic zones occur naturally in some parts of the ocean, but they are expanding due to human activity. The expansion of dead zones is one of the most concerning environmental changes occurring in the ocean today, with implications for marine ecosystems, fisheries, and global nutrient cycles. Natural dead zones occur in places where water circulation is restricted and organic matter accumulation is high. The Black Sea, for instance, has an enormous anoxic zone below a depth of approximately 200 meters. The sea is stratified, with a layer of less saline water sitting atop denser, more saline water. This stratification prevents mixing, and oxygen cannot reach the deep water. Organic matter sinking from the surface is decomposed by bacteria, which consume oxygen. Eventually, the oxygen is depleted, and only anaerobic bacteria can survive. The deep water of the Black Sea contains hydrogen sulfide, a toxic gas produced by bacteria metabolizing sulfates in the absence of oxygen. The concentration is high enough that if the water were somehow mixed with surface water, it could release deadly gas clouds. The Black Sea's anoxic layer is stable and has existed for thousands of years, but it represents a glimpse of what can happen when ocean water loses its oxygen. Similar conditions exist in the Baltic Sea, where periods of stratification create hypoxic bottom waters that kill fish and other organisms. The Gulf of Mexico has a seasonal dead zone that forms each summer, driven by nutrient runoff from agricultural areas along the Mississippi River. The nutrients, primarily nitrogen and phosphorus from fertilizers, fuel algal blooms. When the algae die and sink, bacteria decompose them, consuming oxygen and creating hypoxic conditions. Fish and mobile organisms flee the area, but bottom-dwelling species suffocate. The size of the Gulf of Mexico dead zone varies from year to year, ranging from a few thousand to over 20,000 square kilometers. It is one of the largest human-caused dead zones, but it is not unique. Similar dead zones exist in coastal waters around the world, from the Chesapeake Bay to the East China Sea, from the North Sea to the Indian Ocean. The expansion of these dead zones is alarming. In the 1960s, there were fewer than 50 documented coastal hypoxic zones worldwide. Today, there are over 500, The total area affected exceeds 245,000 square kilometres, an area roughly the size of the United Kingdom. And the problem is worsening as nutrient runoff from agriculture and wastewater increases, as coastal development intensifies, and as climate change alters ocean circulation patterns. But there are also natural open ocean regions where oxygen is naturally low. These oxygen minimum zones, or OMZs, occur at mid-water depths in certain parts of the ocean, particularly in the eastern tropical Pacific and the Arabian Sea. In these regions, oxygen levels drop to near zero at depth of 200 to 1,000 metres, creating a layer of water where most aerobic organisms cannot survive. The existence of OMZs is related to oceanographic conditions. Surface waters are oxygen-rich due to contact with the atmosphere and photosynthesis by phytoplankton. Deep waters are replenished with oxygen by currents that originate in polar regions, where cold water sinks and flows along the ocean floor. But at intermediate depths, in regions where circulation is weak, oxygen can be depleted by respiration and decomposition faster than it is replenished. Despite the low oxygen, life exists in OMZs. Specialized bacteria thrive, some using nitrate instead of oxygen for respiration. Certain fish and invertebrates have adapted to low oxygen through physiological changes. Larger gills, higher concentrations of oxygen-binding proteins in their blood, reduced metabolic rates. These species occupy a niche that other organisms cannot, and they thrive in the oxygen-depleted water. But if OMZs expand, as climate models predict, the consequences could be severe. Warmer water holds less dissolved oxygen than cold water. As the ocean warms, oxygen levels decline. Additionally, warming strengthens stratification, reducing the mixing of oxygen-rich surface water with deeper layers. The combination of these factors is expected to expand OMZs, reducing habitat for most marine species and compressing populations into narrower depth ranges. There is also concern about tipping points. If oxygen levels decline too far, feedback loops can accelerate the process. Anaerobic bacteria produce compounds like hydrogen sulfide and methane, which are toxic to most organisms. If these compounds accumulate, they can poison waters that were previously habitable, further expanding dead zones. Geological evidence suggests that ancient oceans experienced periods of widespread anoxia, with dead zones extending across vast regions. These events, called oceanic anoxic events, are associated with mass extinctions. The mechanisms are not fully understood, but they likely involved a combination of volcanic activity, climate change, and disruption of ocean circulation. Could modern ocean warming trigger a similar cascade? Most scientists believe the risk is low, but not zero. The expansion of dead zones also affects fisheries. Fish avoid hypoxic water, concentrating in smaller areas where oxygen levels are adequate. This makes them easier to catch in the short term, but reduces overall population sizes. Bottom-dwelling species like crabs and mollusks cannot escape and die when hypoxia develops. The Gulf of Mexico dead zone, for instance, kills significant numbers of commercially important species each year, impacting both ecosystems and economies. Efforts to reduce dead zones focus on decreasing nutrient runoff. Improved agricultural practices, wetland restoration, and wastewater treatment can all reduce the flow of nitrogen and phosphorus into coastal waters. But these measures are expensive and politically challenging. Farmers resist regulations that limit fertilizer use. Urban areas struggle to fund infrastructure improvements. And the benefits of nutrient reduction may take years or decades to materialize, making it difficult to sustain political will. Meanwhile, the dead zones persist and expand. Each summer, the Gulf of Mexico dead zone forms, killing organisms and disrupting ecosystems. Each year, the Baltic Sea experiences hypoxic episodes that devastate bottom communities. And gradually, imperceptibly, the ocean's oxygen content declines, a slow suffocation driven by warming and nutrient pollution. The deep ocean dead zones remind us that the ocean is not infinite in its capacity to absorb human impacts. It can be damaged, it can be changed, and those changes can have profound consequences for the life it supports and for the humans who depend on it. The image of water without oxygen, dark and still, can rest in the mind without distress. The recognition that life requires certain conditions, and that when those conditions change, life changes with them or disappears. The slow awareness that the ocean, for all its vastness, is vulnerable. The breathing continues, steady and calm, appreciating the oxygen that flows effortlessly into the lungs, recognizing it as a gift that not all waters can provide. And in that recognition, there is a quiet gratitude, a settling into the present moment and a gentle release into rest. The sunken cities, civilizations claimed by the sea. The ocean has claimed entire cities, not suddenly, not in single catastrophic events, but gradually, as coastlines shifted, as sea levels rose, as land subsided and waters advanced. Around the world, beneath the waves, lie the remains of human settlements, streets, buildings, harbours, temples, now submerged and silent, colonised by marine life, slowly eroding under the action of currents and waves. These sunken cities are time capsules, preserving moments when the relationship between land and sea shifted, when humans were forced to abandon their homes and move inland, when the ocean reclaimed what had once been dry ground. One of the most famous sunken cities is Heraklion, located in the Mediterranean Sea off the coast of Egypt. For centuries, Heraklion was known only from ancient texts, which described it as a major port city at the mouth of the Nile, a centre of trade and religion, but the city's location was unknown, and some scholars questioned whether it had ever existed. In 2000, underwater archaeologist Frank Goddio and his team discovered the ruins of Heraklion submerged in Abukir Bay, about 6 kilometres from the modern coastline. The city was remarkably well preserved, with temples, statues, houses and ships' anchors resting on the seabed. The discovery confirmed the ancient accounts and provided unprecedented insight into life in ancient Egypt. Heraklion sank gradually over several centuries, likely due to a combination of factors: soil liquefaction during earthquakes, subsidence of the Nile Delta, and rising sea levels. By the 8th century CE, the city was entirely underwater. For over 1,000 years, it remained hidden beneath sediment and water, forgotten, until sonar and diving technology allowed it to be rediscovered. Another sunken city, Pavlopetri, lies off the coast of southern Greece. Dating to around 2800 BCE, it is one of the oldest submerged cities ever found. The city was small, with perhaps a few hundred inhabitants, but it was sophisticated, with paved streets, buildings, and a complex drainage system. The city sank around 1000 BCE, likely due to earthquakes that lowered the land relative to sea level. Divers exploring Pavlopetri found pottery, tools, and other artifacts, along with the remains of buildings remarkably intact. Because the city was covered by sand soon after sinking, it was protected from erosion and biological activity. The site provides a rare snapshot of Bronze Age urban life, frozen in time at the moment the city was abandoned. In India, the submerged ruins of Dwarka lie off the coast of Gujarat. According to Hindu texts, Dwarka was the capital of Lord Krishna, a city of great splendour that was eventually swallowed by the sea. For centuries, this was considered purely mythological, but underwater explorations beginning in the 1980s discovered stone structures, walls, and artefacts at depths of up to 40 metres. The dating of the structures is controversial. Some researchers suggest they are remnants of a city thousands of years old, possibly matching the legendary Dwarka. Others argue the structures are more recent, perhaps medieval, or that they are natural formations misinterpreted as artificial. The debate continues, but the site has renewed interest in the possibility that some ancient legends may preserve memories of real events. The most extensive sunken landscape is Doggerland, a region that once connected Britain to continental Europe. During the last ice age, when sea levels were over 100 metres lower than today, Doggerland was a vast plain, home to rivers, forests, and human populations. As the ice sheets melted and sea levels rose, Doggerland was gradually inundated. By around 6500 BCE, it was mostly submerged, and by 6200 BCE, Britain had become an island. Fishing trawlers operating in the North Sea occasionally haul up artefacts from Doggerland: stone tools, bones of mammoths and other extinct animals, and even fragments of worked wood. These finds provide glimpses of a lost landscape, a place where people lived for thousands of years before the sea claimed it. The inundation was slow enough that populations could retreat inland as the waters advanced, but eventually the entire region was lost. The submergence of coastal settlements is not ancient history. It continues today. In the Pacific, low-lying island nations face existential threats from rising sea levels. In Bangladesh, Coastal villages are abandoned as saltwater intrudes into farmland and homes are flooded. In the United States, communities in Louisiana are disappearing as wetlands erode and the Gulf of Mexico advances inland. These modern examples differ from ancient sunken cities in that we can document the process in real time through photographs, videos, and personal accounts. We can watch as homes are abandoned, as streets flood with increasing frequency, as entire communities relocate inland. In a few centuries, these sites may become underwater archaeological sites, studied by future researchers trying to understand how 21st century humans responded to environmental change. The archaeological study of sunken cities has revealed important information about ancient civilizations, trade routes, construction techniques, and daily life. But it has also revealed something more poignant: the impermanence of human settlements. Cities are built with the assumption of permanence, as if they will stand forever. But the ocean reminds us that forever is a long time, and that coastlines are not fixed. They shift, they change, and what is land today may be sea tomorrow. The image of a sunken city, streets lined with buildings now home to fish and coral, can rest in the mind. The recognition that human achievements are temporary, that even our grandest constructions will eventually crumble and be reclaimed by nature. But there is no sadness in this recognition, only acceptance. The ocean does what it has always done, advancing and retreating with the cycles of climate and geology. And humanity adapts, as it has always adapted, moving when necessary, rebuilding when possible, and continuing forward. The breathing slows, the mind settles into that acceptance, that recognition of impermanence, and in that settling, there is rest, the kind of deep rest that comes from releasing the illusion of permanence and accepting the flow of time. The midnight zone, realm of eternal darkness. Below 1,000 meters, sunlight does not penetrate. The ocean enters a realm called the midnight zone, or bathypelagic zone, where darkness is absolute and permanent. No dawn breaks here, no sunset colours the water. There is only blackness, uninterrupted, eternal, a darkness so complete that human eyes, even fully dark adapted, can perceive nothing. Yet this zone is inhabited. Creatures have evolved to live in this lightless realm, developing adaptations that allow them to navigate, hunt, and reproduce in conditions that seem incompatible with life. These organisms represent some of evolution's most creative solutions to environmental challenges, proof that life can persist in even the most extreme circumstances. Bioluminescence is common in the midnight zone. Unable to rely on sunlight, many creatures generate their own light through chemical reactions. The light is typically blue-green, the colour that travels farthest through water. Fish use bioluminescent lures to attract prey, glowing spots to identify mates, and flashing patterns to confuse predators. Squid release clouds of bioluminescent ink as decoys. Jellyfish pulse with light, creating beautiful displays that serve purposes we do not fully understand. The anglerfish is perhaps the most iconic resident of the midnight zone. Female anglerfish have a modified dorsal fin that extends forward over the mouth, tipped with a glowing lure containing bioluminescent bacteria. The fish hangs motionless in the water, the lure glowing, waiting for prey to approach. When a small fish or shrimp investigates the light, the anglerfish strikes with astonishing speed, its huge jaws engulfing the prey whole. Male anglerfish are tiny compared to females, sometimes 1/10 the size. When a male encounters a female, he bites onto her body and fuses permanently, his circulatory system merging with hers. He becomes a parasitic appendage, providing sperm when needed but otherwise reduced to little more than a reproductive organ attached to the female's body. It is one of the most extreme examples of sexual dimorphism in the animal kingdom. The midnight zone is also home to giant squid and colossal squid, the largest invertebrates on Earth. These deep-sea predators have eyes the size of dinner plates, the largest eyes in the animal kingdom, evolved to detect the faintest traces of bioluminescence in the darkness. They hunt fish and other squid, using tentacles lined with hooks and suckers to capture prey. Encounters between giant squid and sperm whales, which dive to depths of over 2,000 meters to hunt them, are epic battles that occur in complete darkness. Sperm whales bear scars from squid tentacles and hooks, evidence of struggles in the abyss. The whales use echolocation to find their prey, emitting powerful clicks that bounce off objects in the darkness. The squid, when detected, fights with all its strength, but the whale is larger, more powerful, and ultimately victorious. The midnight zone supports less biomass than shallower waters because food is scarce. Most organisms depend on marine snow, the constant rain of organic particles drifting down from the sunlit surface. This detritus, dead plankton, fecal pellets, fragments of larger organisms, is the primary food source. It settles slowly, taking weeks to drift from the surface to the deep sea floor, and by the time it arrives, much of its nutritional value has been consumed by organisms in intermediate depths. As a result, midnight zone organisms have evolved to be extremely efficient. Metabolic rates are low, conserving energy. Many species are gelatinous, reducing the energy cost of maintaining tissues. Some fish have weak muscles and fragile bones, sufficient for drifting in the water but incapable of sustained swimming. They are ambush predators or scavengers, waiting for food to come to them rather than actively hunting. The midnight zone extends from approximately 1,000 meters to 4,000 meters depth. Below that lies the abyssal zone, and below that the Hadal zone of the deep trenches. Each zone has distinct characteristics, but all share the common features of darkness, cold, and high pressure. Pressure in the midnight zone exceeds 100 atmospheres. At these pressures, gases behave differently, proteins can denature, and cell membranes can fail. Deep-sea organisms have evolved biochemical adaptations to cope. Their proteins are structured differently, their cell membranes contain different lipids, and their bodies contain compounds that stabilize biological molecules under pressure. One such compound is trimethylamine oxide, or TMAO, which accumulates in the tissues of deep-sea fish and helps proteins maintain their structure under pressure. The concentration of TMAO increases with depth, allowing species to inhabit ever deeper waters. But there is a limit. Beyond a certain depth, estimated at around 8,500 meters, TMAO concentrations would need to be so high that they would interfere with other biological processes. This may represent a fundamental limit to how deep fish can live. The midnight zone is also a place of slow time. Metabolisms are slow, growth is slow, reproduction is slow. Some deep-sea fish may live for decades or even a century, growing slowly throughout their lives. Orange ruffy, a commercial fish species that lives at depths of 600 to 1,800 meters, can live for over 150 years. Harvesting such long-lived species is problematic because populations cannot recover quickly from overfishing. Sound travels well in the midnight zone. Whales use low-frequency calls that can travel across entire ocean basins, communicating with other whales hundreds or thousands of kilometers away. Some fish produce sounds by vibrating their swim bladders, creating booms or drumming noises. The purpose of these sounds is not always clear, but they likely serve roles in communication, territory defense, or mating. Human exploration of the midnight zone is limited. Submersibles can reach these depths, but missions are expensive and infrequent. Remotely operated vehicles provide more consistent access, but they can only observe, not collect samples easily. Trawling, dragging nets across the seafloor, brings up organisms, but often damages them and provides no information about their behavior in their natural environment. As a result, much of what lives in the midnight zone remains unknown. New species are discovered with almost every deep-sea expedition. Some are bizarre, defying easy classification. Others are similar to known species but adapted in subtle ways to their specific depth range. The midnight zone reminds us that darkness is not empty. It is full of life, full of activity, full of behaviors and interactions that occur beyond human perception. The organisms there have never seen sunlight, never will see sunlight, and do not need sunlight. They live in a world defined by different rules, where light is a tool created by organisms rather than a gift from the sun. The image of the midnight zone, vast and dark, populated by strange creatures glowing softly in the blackness, can rest in the mind. The recognition that life persists in the absence of light, that evolution is creative beyond imagining, that the ocean's depths hold wonders we're only beginning to glimpse. The breathing slows to match the slow metabolism of deep-sea life. The mind descends into that darkness, into that stillness, finding no fear there, only quiet. And in that quiet darkness, sleep comes naturally, gently, like sinking slowly through deep water. The ocean holds its mysteries still. The journey through the deep sea has been long, traversing mysteries both documented and unexplained, encountering phenomena that challenge understanding and creatures that defy imagination. From the bloop's enigmatic call echoing across an ocean basin to the silent darkness of the midnight zone, from the pressurized depths of the Mariana Trench to the frozen preservation of ghost ships adrift in ice, the ocean has revealed itself as a realm of endless wonder and profound unknowing. What have these mysteries shown? Not answers, certainly. The ocean does not provide easy answers. It offers instead complexity, nuance, and the humbling reminder that human knowledge has limits. We map the seafloor with sonar and find formations we cannot explain. We record sounds in the deep and hear things we cannot identify. We discover creatures thought extinct and realize how much remains hidden in the vastness of the water. The ocean is not mysterious because it tries to conceal. It is mysterious because it is vast beyond human scale, deep beyond human reach, and operates by processes that unfold over millions of years. It is mysterious because we have only recently developed tools capable of observing it, and those tools reveal only glimpses, fragments, brief moments of visibility in an environment that is mostly invisible to us. Every expedition into the deep returns with new questions. Every dive reveals something unexpected. Every sonar scan shows features that require explanation. The more we learn about the ocean, the more we realize how much we do not know. The boundary of knowledge expands, but the region of mystery expands faster. And perhaps that is as it should be. Perhaps the ocean is meant to remain partially unknowable, a reminder that not everything can be measured, catalogued, and understood. Perhaps its mysteries serve a purpose beyond satisfying curiosity. They teach humility, patience, and respect for forces larger than ourselves. The creatures of the deep have no awareness of being mysterious. They simply exist, following patterns shaped by evolution, inhabiting niches where their adaptations allow them to survive. They do not glow to enchant human observers, but to attract prey or mates. They do not grow to enormous sizes to impress, but because the physics of buoyancy and the scarcity of predators in the deep allow it. They are not strange. We are simply unaccustomed to their world. The ocean phenomena, the sounds, the lights, the formations, are not mysteries to themselves. They are simply what happens when water and rock and life interact over vast spaces and deep time. A sound propagates through the ocean because water is dense, and sound travels well through it. A bacterial bloom glows because certain bacteria produce light. A geological formation appears angular because rock fractures along planes determined by its structure. The mystery exists in the gap between what occurs and what we understand, not in the phenomena themselves. As the mind processes these ideas, as the images of the deep sea drift through consciousness, the glowing pyrosomes, the frozen captain of the Octavius, the deep scattering layer rising toward the surface at dusk, the silent wrecks of submarines on the seafloor, there is a sense of completion, not of knowledge acquired, but of journey undertaken. The ocean remains. It was here before humanity evolved, and it will be here long after humanity is gone. It will continue to generate mysteries, whether or not anyone is present to wonder about them. The bloop may sound again, or it may not. The Yonaguni monument may eventually be explained, or it may remain ambiguous. New creatures will be discovered, and some will challenge our categories and assumptions, and that is acceptable. That is even, in a way, comforting. The ocean's mysteries are not problems waiting to be solved. They are features of a world that exceeds our grasp, reminders that the universe is larger and stranger than any model we construct to explain it. The breathing has become slow and deep, the rhythm of waves on a distant shore. The body has relaxed completely, muscles releasing tension accumulated throughout the journey. The mind has travelled from the surface to the abyss and back, encountering wonder and strangeness, and now it rests, satisfied not with answers but with the quality of the questions. In the deep ocean, in the cold darkness, in the silence broken only by occasional sounds of life and geology, there is peace. Not the peace of understanding, but the peace of acceptance. The ocean is what it is. Its mysteries remain mysteries. And in that remaining, in that persistence of the unknown, there is something valuable, something worth preserving. The eyes close naturally. The boundary between waking and sleeping becomes indistinct, like the boundary between sea and sky on a calm day. Thoughts drift like marine snow, settling slowly, carrying fragments of images and ideas downward into the depths of unconsciousness. The ocean holds its mysteries still, and in the holding, in the keeping of secrets, in the vast unknown spaces between what we have discovered and what remains to be discovered, there is room for wonder, room for imagination, room for the mind to rest in the knowledge that not everything needs to be known. The descent into sleep is gradual, gentle, like a submersible sinking slowly through layers of water, each layer darker than the last, each layer quieter, until finally the bottom is reached and there is only stillness, only silence, only the deep and dreamless rest of the abyss. The ocean waits, the mysteries remain, and sleep comes at last. Complete and profound, like the darkness at the bottom of the deepest trench, where pressure and cold and silence combine into something that is not emptiness, but fullness, not absence but presence, not end but continuation. Rest now. The ocean will still be there when consciousness returns, its mysteries will wait, its depths will remain. And the questions, those beautiful unanswerable questions, will be there too, patient and eternal like the water itself. Sleep deeply, sleep well. The ocean holds you in its vastness, and in that holding there is safety, there is peace, and there is the gentle assurance that some things are meant to remain unknown, some darkness is meant to stay dark, and some mysteries are meant to endure. The final breath deepens, the final thought fades, and consciousness dissolves into the same darkness that fills the ocean's depths, complete and perfect, and finally, blessedly, still. End of script.